almost missed it. Almost, but I didn't. Right on time. Right on time. What's up, Sally? How you doing? Good day, Imgene. That's the pup just crying. I'm sorry. YGBSM, how you doing? 88. Thank you so much for sticking around me for 9 months. Can't believe it, you know? We basically have had a baby now. What's up, CSBNDC? On time crew, hashtag always. What's up, diarrhea? On time, every time. I'm proud of myself. I really am. We always were a couple minutes late last time. We were always like a minute, you know, because I would go get my coffee. I would decide to go get my coffee right at I think we were doing it at 8 at that time. I was at like 7:58. I will run down. I'll say, today I can get coffee in that amount of time. Nope. It's not true. What's up, Wolfgang Blitz? I love the name. Thank you so much for the 100 bits. I like the Shamrock. Thank you very, very much. Super appreciative of it. But tonight is going to be fun. Tonight we're going to be diving into introduction to algorithms. We're going to start putting together all the tools that we've learned to be able to start to build some houses or build some structures. And I think it's going to be fun. I think tonight is, you know, where everyone kind of gets to when they want to start learning how to code. I imagine this is where they want to start. Kind of like when you want to learn how to do karate and you assume day one you're going to be chopping boards with your hands and doing stuff like that and sweet roundhouse kicks, but then you find out that you're going to be doing like push-ups and like other things to you know, practice and to get your body ready for the things that you're going to be doing, learning a lot more things about, you know, the theory of stuff. So tonight is going to be, you know, it's going to be nice. I think we're gonna go over some slides as usual. They are in the Google Classroom. I'll share the link out in a second, and then we're gonna get hands-on and we're just gonna start going through a couple. Tonight we're gonna be using exorcism.io. I'm gonna introduce you to Exorcism. There are a number of platforms like this. I just think Exorcism is a nice approachable one, at least for the intro, like the starter problems, but I'll help identify some other sites to kind of start with this as well. And we're just gonna get comfortable solving problems. We'll go through and solve some together, and we're just gonna start having some fun. This is not the only course we're gonna have on algorithms. There's another course on algorithms tonight. We're not gonna be diving, you know, we're not gonna be getting into, you know, merge sorting and bubble sorting and stuff like that tonight. We're gonna start learning how to think about how to problem solve like a programmer, like learning how to approach problems so that you're comfortable. We'll learn all the other stuff next time. Like all of the things that you would learn in an algorithms course, we'll learn like next time. Tonight is more of a learn how to problem solve, get introduced to what algorithms actually are instead of this big fancy scary word. What's up, greatest Rob? Good to see you. Creator at night, how are you doing? So I have way too many tabs open. I don't know how I have so many tabs open. I know you can't see my screen. Let me just get set up. I think I'm set up everywhere else. Let's minimize this. Let's open up the metrics to make sure my stream's not dropping any frames. Let's get that where I can see it right here. Excellent. Let's see. Oh, you already got the slides for me. I appreciate that. See, you all are amazing because I was gonna do that and now you did it for me. Were able to send me that recommendation engine. Oh, I was not. I couldn't, when I first searched for it, I couldn't find it. But I didn't look that hard, so I apologize. Let me try to remind me a little bit later towards the end, and I'll see if I can do some Google magic and find it. Password. Do you need a password for the slides? You shouldn't. If not, I may have to give that may not be a publicly available link. But we'll see. Drive. It may make it so that you have to be like in my organization. Intro to algo. So let's head over to Academy View. Automation engaged. I appreciate that. Let me know if you all are able to get in there doing that. Whoa, what is that? All right, I think we're good. But yeah, tonight's intro to algorithms. We're gonna keep it nice and simple. We're gonna solve some problems tonight. And tonight is gonna be good because this is gonna help set you on your path to, as we start our 100 days of code next week. Whether you're participating or not, even if you're just, you know, going to be practicing coding as you can, it's okay if you don't, it's okay if you do not do the whole 100 days, but I encourage you to try, do your best. this will get you going on being able to, you know, go to like hacker rank and all these code wars and stuff if you want to try to do some stuff like that. But also if you want to start preparing for jobs, a lot of times they're going to be asking you, man, my glasses are dirty. They're going to start asking you some of these problems and to solve certain problems and things like that. And so this is really going to start to set you on the course where you're able to feel comfortable approaching those things whenever you get them. Okay. What's the startup music? The startup music. The startup music is it's a song by RMR, by a guy named Rumor. I think that's how you're supposed to pronounce it, but it's called Dealer, and it's just the instrumental for Dealer. I don't know why I did that, but it's particularly the remix with Future and this guy. I know he looks crazy. The videos are very interesting. This is not the remix, but it's to that song. This is actually it right here, with Future and Lil Baby. But that's what the background music is for the intro video. I like the beat. I'm a big instrumentals fan. I really like instrumental music a lot. Yeah, you'll need to join the Google Classroom. I can also share the link. Whoa, the share options changed. Get link. They changed a lot. Restricted. Anyone with the link. They made it easier. Look at that. They got some DevOps going on. They got that out of here fast. So activity feed, but instead of activity feed, we want to do chat, and we want to make this page bigger because I can never read this because it's always tiny. But there we go. That link should work for everyone who needs it. Got my water, you know. I think I'm ready. I think we're ready. Allow us to get through as much or as little as we want to tonight. Intense viewing today. I don't think it'll be that intense today, to be honest. I think it'll be nice and fun, and I do think that people who, if this is your first time, you know, this is your first go at learning how to code, I think tonight is going to be, when we get into stuff, I think you're going to feel left behind as we start moving through some things. We're going to move slow, but I think you're going to feel left behind. That's okay. I want to give you that up front. I encourage you, we're going to talk through some things that are going to help you kind of approach these things. And as you just start to, it's going to be valuable just to kind of sit and think and really, like, for a limited amount of time, and like, you know, engage as much of your brain power as possible and just see what kind of connections you can make between the things that we're doing. It's okay. Not a big deal. You will get there. I promise you'll get there. Everyone gets there. If you just keep trying, you just keep looking at it, eventually it'll start to click. But yeah, just we're gonna talk about how to solve some problems. So tonight is, let's do it. Let's hit the button because we got to use it once per time.
Introduction to algorithms. Problem solved.
All right, let's go. Actually, tonight, focus on the concepts. I really want to stress that. Just focus on the concepts. The goal of tonight is not to make you a super coding whiz, a problem solving whiz, but just focus on the concepts, because then you can start to build on those things so that you can be a whiz in the future. Okay, let's start with the very basics of the stuff. What are algorithms? Now, you might look over on the right and you might be thinking in your mind something equally as complicated. Whenever you hear the word algorithms, I know it sets off something different in everyone's mind, but all an algorithm is a process or a set of rules to be followed in calculations or other problem-solving operations, especially a computer. Now, what does that mean? All it means is a process to get to an end result or end goal. So a lot of times people are teaching algorithms, they like to use the analogy of, hey, if I asked you how many people are in this room, what would be your process? That is an algorithm. Your process might be to look around, to point, and to count each person in the room. That is, in fact, a way for you to get to that end goal. It's a way for you to calculate the desired end goal, the desired end result. So all the algorithm is the steps, the process or the steps to get a desired outcome. So it isn't anything super crazy. It can be very, very simple. It's not this complex mathematical object. It can be, an algorithm might be, to add two numbers together or something. That's the entire algorithm. And so that's all it is. It's a process or set of rules, basically, followed in calculations or other problem solving operations, especially by a computer. That's all it is, just a process. So the goal of these algorithms is really to solve problems. It's how do you solve problems? And basically you're going to be, to solve problems in computing, solve problems in programming, you're going to be applying algorithms to those things to get to that end state. You're going to be defining a process via your code for calculations to get to that end goal. And that's what we're going to be doing. So how do you do it? How do you solve problems? The very first way, the very first step is you got to comprehend the problem. You need to understand what the problem at hand is. So how do you do that? You consume the problem until you are comfortable. And I really want to stress that. Not only consume it until you're comfortable, consume it in as many ways as needed until you're comfortable. So to solve a problem, you must first understand the problem, even if it means reading the problem 10 times, even if it means bringing it to someone else to read and to try to restate to you. You need to have a good understanding of what it is that you're trying to solve to be able to properly solve it. And this is the first part. I think people don't take the time to truly comprehend. And again, it can be tough. It can be frustrating when you read through something and it makes no sense. But you must comprehend the problem first, even if it means reading it 10 times. And that is, we're going to focus on trying to understand that tonight. And the tools that we learn tonight will help you confirm that you understand it, or at least help guide you to the point of understanding. So really quick, there aren't many slides tonight because we're going to hop right into it and practice these things. But to help you comprehend it, you probably are going to need to break it down, especially if you read it 10 times and you still don't fully understand it. Break it down so that you can more easily comprehend it. So the saying does in fact go inch by inch. Life is a cinch, yard by yard. Life is really hard. And so this is true in programming as well. This is true in problem solving across the board. Sometimes you got to stop and look at the entire forest you got to stop looking at the entire forest and start looking at the individual trees. Now, this is the opposite of what that saying usually is. It's stop looking at the trees, take a step back so you can see the whole forest. But in this case, in problem solving, sometimes it's quite the opposite. You got to stop looking at the macro and the entire elephant of the problem and start to dig down and look into the smaller pieces to help you understand. So break that problem down into manageable pieces. And this will take time for you to begin to effectively do and to understand what pieces make sense to break out into their own parts. But it's okay. It's something that you'll get better at over time, but you got to practice it. So read through the problem, understand the problem, take the different pieces that your mind can discern as you're reading through and breaking them up into different pieces so that you can try to figure out how to solve that problem. Again, it's much easier when you're trying to solve these much smaller problems instead of this giant thing all at once. It can be very, very, very confusing. Sully, appreciate that. Thank you so much for sticking around for 2 months. Thank you for the 2 months in a row. Really do appreciate you. Got to learn how to think abstractly. It's tough. It's definitely tough, and how abstractly construct architectures and manage them. Yeah. It is. It takes time. It is you are starting to learn how to solve problems, not quite like a human would solve problems, but how a computer would solve problems. And so you do need to be able to do, it takes time to get there, and it's okay. Trust me, I'm not, I'm pretty good at solving problems. I'm not an amazing, algorithmic programmer at all. But I am really good at solving problems, and that's what's helped me be able to do the things I need to do. So when I solve algorithms, they aren't always super efficient or amazing, but hey, I can get things done when I need to, and that's something that I'm working on. I'm getting better at those things. So it does take time, and it's okay. I'm sure there are many people with way less experience than me who are much better at this because they've practiced exactly this. They've practiced really owning their problem solving skills. I got time. What will we try solving today? Heaps to tries. See, no, we will. You picked all the really tough things. We are gonna start very simple, very, very simple. We will get to some of that stuff in the algos part 2, though. It's gonna be a pretty large jump from what we do in this algorithms course to the second one. And again, that's just to get you introduced. Like today is going to be dipping our toe in the water and like slowly, getting down to our waist. And then Algos 2, we're going to be diving off the high dive. I think that is in 3 classes from now. But yeah, we're going to be doing some more simple things tonight. We're going to keep it simple. So break it down. That's how you can begin to understand the problem. That's how you can begin to start to solve the problem effectively. Break it down into manageable pieces. It is okay to do, and you should in fact do it. All right, tonight we're going to talk about pseudocode really quick, and let's see if I have whiteboard access tonight. I have no idea. Let's see, whiteboard it up. So first, let's talk about what pseudocode is. Lots of words on here. Don't sweat it. This code is in fact hashtag FUGAZI. I'm teaching you all, anyone who's not familiar with that word, I'm teaching you all some American slang. I actually think when I looked it up, I mean, I know what FUGAZI means to me, but I wasn't sure if it was a real slang word from somewhere else. And it said it was an Italian slang word, which was interesting. You probably have heard it in a lot of hip hop and rap songs over the past few years. But yeah, it means bogus. It means fake. And so this code is FUGAZI. You learned something new tonight. But in computer science, pseudocode is an informal, high-level description of the operating principle of a computer program or other algorithm. It uses the structural conventions of a normal programming language, but is intended for human reading rather than machine reading. So what pseudocode is pseudocode is a way for you to express the logic of your algorithm, of your computer code, without having to write actual code. This is a very effective thing to learn how to do. It's not a real pseudocode's not, it's none of it's real. It's not a real thing. So there's no real right way to do it. There are some preferred methods that I've seen over the years of how to express certain things, but pseudocode's not real. And so you can structurally try to express how code works, like when you understand how things work without needing to know the syntax. Being able to pseudocode well will really help you on coding interviews, because then if someone asks you to do something, and I've gotten jobs when someone asked me to do something in a certain language, had no idea how to do it in that certain language when you're whiteboarding or something. So if you pseudocode it out, if you work through the logic in something that is code-like but not actually code, it really helps to show that you know how to think through the problem without needing to know, where the semicolons go or to know what function does this or that. So it is really, really nice. So the way that pseudocode might work is let's head over to our whiteboard. Do we have it? We do in fact have the whiteboard going. And so pseudocode would be it's written in a lot of different ways. People do it in different ways. Like I said, there are some standards on how to write to express some of the things, but maybe we have a piece of code that says, hey, check that check if, let's see. Whoa, I'm still learning how to use this Apple Pencil. I'll be struggling. Check if I is greater than 5. If so, print happy day. I don't know why you would want to do this. All right, and so maybe this is an algorithm that someone gave you on a coding challenge, and it says, hey, I need you to write some code to check if I is greater than 5, and if so, write happy day. And now this is going to be a dumb example because I basically wrote out kind of what pseudocode would kind of be, but you can write your code if you're like, hey, I don't really know the syntax for an if statement or something like this. And so you can write, you can say, hey, I would do an if statement here, and I would say if, I is greater, and you can write the word greater, or if you know the greater symbol, now we're writing actually real code. Greater than 5, you could say, then you can just put a then in here, then echo or print or whatever you want, happy day. And then you could maybe write in here, or else do something else. and we'll write some more pseudocode as the things get harder. We're going to write some pseudocode to solve all the problems that we're going to do tonight. But it's a way for you to kind of just mess around, not mess around, but to in a structured way, kind of following the structure of coding languages using the same tools. So I've seen people do loops, like if you have to loop through something. I've seen people say, hey, if 5 is less than X, I've seen them do loops like this, like they'll either say loop times 5 and then some code like print something. And again, it's very informal, it's very free-flowing way for you to describe the logic of your code. It is it's again, it's a good practice. It's a really good way to kind of get started in your code before you actually put any code on paper. If you're trying to work through the logic of the code, if you're not sure how to get there yet, pseudocode's a great way to express your ideas. And actually, let's take a look at real quick at some pseudo code, and let's see if we can see some good examples. I know sometimes I see some pseudocode that's like super advanced. That's Eurocode is not pseudocode. And maybe, yeah, so check this out a little bit here. They write the word, oh wow, this is a terrible pop-up, but they write the words like program start. This is where the program starts, and initialize variable A equals 0 and initialize variable B. Start infinite loop. So we talked about how to set up infinite loops. And so they wrote the words out, start infinite loop, and call this function. And it's again, it's very informal. You're just trying out some things. You are kind of describing what's happening using a programming type structure, but without having to incorporate the syntax and exact things of what needs to happen. End infinite loop here, call this function, delay for 500 milliseconds. So it's a way for you to kind of just work through the logic of your code. Really nice to do. We're going to practice some of that tonight. There, like I said, there's no right way. We may look at some other one and like it looks very different than this. What is this? This is a little do's and don'ts of writing pseudocode. Let's I haven't even read it, but I think this I like the do's and don'ts. Let's add this really quick. Hopefully it's good. If not, it's my bad, but like it'll help. I think it's something that you'll pick up over time though. And like I said, everyone's will be different. Material do's and don'ts of, I'm gonna write P code because I can't spell pseudo. You got to be smart. If you work smart, life will be easy. If you don't work smart, life will be hard. And we'll paste this in just for now. We can update this later. Put it under here. Like I said, hopefully it's good. But go ahead and check that out. That is in there now. So, a little bit on pseudocode. Like I said, we will definitely write some pseudocode tonight to work out our problems. FUGAZI equals wild. No. FUGAZI equals fake. It equals it's your diamonds are in fact FUGAZI. My diamonds are in fact not FUGAZI. We don't do any fake stuff over here. Let's go help with UML. Yeah. You get a Wacom Cintiq. I'll try out a Wacom Cintiq. I think I've heard of these. Is that better or worse? Can't tell if you're trolling me or not. I've heard of these Cintiq things. I want Microsoft to send me. Oh, what is this? Excuse me. This looks fancy. And we all know that I'm probably the best artist, at least on the East Coast, maybe in the United States. So maybe this is what I need. Maybe this will help. Where's Wacom? You guys want to donate one of these to me because I don't want to pay for it. But yeah, we can get that Cintiq, because I do want to get the little paper-like skin for the iPad because I find it very difficult. I'm already not a great, I don't have great penmanship already, but because the screen is so like slick, it makes it even tougher. It makes it way tougher to write effectively. So I kind of want to they have like a paper overlay for your iPad. I'll try it out. Who knows? You know, I do my best. I definitely do my best. This is more like a user story in pseudocode. Yeah. We'll write some better pseudocode in a second. Yep, Google Classrooms has a lot of stuff in it. Not as much as I would like, but it has most of the stuff in there. You would never troll. People are just, you know, I thought we were all friends, and now people just feel okay lying to me. But respect, it's okay. Had our drawing tablets. Yes, on drawing tablets. They can get expensive. I was surprised at how much even the iPad Pros cost. I was like, I might as well just get a laptop here, but I already had laptops, already had desktops. And so I probably didn't even need the Pro, but you know, I don't spend my money on many different things. I wasted on tech and cars, and it's a problem. Okay, let's keep moving along so we can actually get to the fun stuff tonight. So after you've comprehended the problem, after you have read it a lot of times and you really understand it, and then you've broken the problem down into consumable pieces which you can use to start solving that problem, and after you've written the pseudocode out to solve those little pieces. So now pseudocode's not necessary. It's just a tool that you can use on your journey to being able to solve these things. I highly recommend using pseudocode techniques while you're learning how to solve algorithms to get your thoughts together and gather your thoughts, learning how to use it to express your thoughts. And then you code. That's like, after you've done all that, then you can start to actually write the code that's necessary for you to solve your problems. Now, when you're writing the code, remember, all you're doing is you are using the tools that you've picked up. So we're using these tools, we're using our variables, and we're using our different data types, and we're using our different data structures. We are using our all of the different what are those things called that we learned, operators that we learned, comparison operators, all that stuff. We're taking all that and we are putting them together so that we can solve a problem where we're pulling the tools out of the toolbox to hammer in nails. We see a screw, we use the screwdriver that we picked up. You know, we got to get the nail gun out sometimes, you know, got to get the plaster and all that stuff, and so that we can start to get to the end. So whip out these tools and see what you can do. Now remember, make it work first, then make it right, then make it fast. It's okay in the beginning. Focus in the beginning on making it work. You can brute force a lot of problems, and in the beginning, I do want you to do that. And welcome, Cyber Barbie. Welcome to the channel. Thank you so much for the raid. Hello, Cyber Barbies. That's what I'm denoting, the Cyber Barbie community. I am also a Cyber Barbie myself. So welcome to the channel. So good to have you. What were you all doing today? I wanted to stop by, but I actually didn't finish working until like 5 something, which was unfortunate. What's up, Web Food? What's up, One Pocket Pimp? What's up, Aaron? Back on. Aaron, you know, what a great name, Aaron. Welcome to the channel. What's up, Dandy McGee? Lita, always good to see you. Welcome. What's up, Shahan? You know, how you doing? Welcome, Raiders. Come on in. We are learning how to solve some algorithms tonight. We're learning the steps that you need to take to solve some dope problems using the computer. All these emotes are the only thing I don't like about my emotes is my dreads look funny on them, but it's all good. But I appreciate that. I definitely appreciate that, One Pocket Pimp. Yeah, but shout out to Cyber Barbie. First off, my bad. I am struggling over here. I have too much going on my desk right now. Cyber Barbie. Again, appreciate your time. Appreciate you, Raiden. Appreciate you coming over here after your stream today. But how was your stream? You guys did some more Python stuff today? I know you've been diving into some. You were getting pretty far in the things that you were working on. What were you guys doing today? Make it work. If anyone has any tips on Python to create databases, please forward them my way. That's interesting. After last night, it looks like you want to create some stuff with Python. We can definitely talk about that. A little bit later. I'm interested to see what you're trying to do to determine what kind of database you need. But yeah, with a giant sub gift war, not much coding, that's a perfect day. Sometimes it's not about coding, it's about gift wars. Gifts are great for everyone, and I'm glad you guys got to do that today. I love that toolbox, especially when you close it, it resets the default rotation. I mean, it is in fact a nice toolbox. We'll have to build one for ourselves. But absolutely, whip out the tools. Take the tools that you've been learning, take them out and start to use them to solve problems. Now, you're not gonna have all the tools that you need to solve every problem. Sometimes you're gonna need to go out to the internet or go down to the Lowe's or to the Home Depot and rent a tool and learn, get a new tool in your toolbox. But again, everything that you learn, think about them as tools, because that's what they are. You're not memorizing how to do a certain thing. You are learning how to use these tools to solve a specific problem, and that's all we're doing. But again, I really want you to, in the beginning, I want you to focus on this. Make it work, make it right, make it fast. And what will happen as you start to get better, as you start to learn new things, your make it work and your make it right will be a lot, they'll start to get closer together. A lot closer together. In the beginning, you're going to be making things work and it is not going to be right, but that's okay. Functioning code, depending on what you're doing, the only goal may be to make it function. So making it work will help you start to learn, will help you start to understand things again. And then as you pick up more skills, as you're able to optimize a little bit better, you'll be able to start to make it while you're making it work. You'll be getting closer and closer to that making it right. And then making it fast is the last thing. Depending on some jobs, that's the number one thing. But making it work is what I want you all to focus on in the beginning, and use those tools to make it happen. And the last thing, we're all done with our slides tonight already. Let's time to practice. We're talking about practice, man. You got to practice. You got to get started. Let's take a look at some things. So tonight I'm gonna introduce you to something called Exorcism, which is a platform that's going to help us solve some coding problems. We'll talk about the reason why we're using it after we get on there. It is not the only place to get coding challenges. It's not the only place that I want you to go, but it's just kind of where we're going to be centering around for a little while. So let's head over there right now. What I sent to you all in the Google Classroom is actually a link to join our team. So Exorcism, another reason we're using Exorcism is it has a team functionality. But head over to exorcism.io. You can sign up with your GitHub. And let's get over here. Yeah, just head over. Take some time. Simply sign up. Again, you can just sign up with your GitHub. I'm going to sign in with my GitHub just to kind of get in there. We'll walk through the platform. We'll get an understanding of how it works. We'll start to pull some challenges down, and we'll get going now. It might be easier for me to take some time out to give you upload. I might create a repo really quick to upload the challenges that we pull tonight, because it does take a little bit. It has its own command line tool, and it takes a few steps to set those up. We're going to go through it because I do not think this computer is set up for it, but I don't want people to get stuck on that. That is not the important thing to do tonight at all. And so I may just give it to you to download from GitHub right now, just to make it a lot easier. So I think that's exactly what we'll do. And maybe part of the what you do after this is to go get the CLI set up for this. So yeah, that's what we'll be doing. Using Python script, I need to parse out available data and save it to a SQLite DB for recommendations tool. Okay. Or library to use, I can figure out the rest. Yes, so there is a SQLite Python package library to use to. Are you talking about a library to use to parse out the data? What kind of to parse out? Do you know what where the data lives? Is the data in a CSV? Is the data in a text file? Is it what kind of file is it in? Or where is the data that you're going to be grabbing? That's a good question, Dandy. What would a programmer's toolbox look like? Probably really weird, honestly. But maybe we'll make a version that we think it's gonna look like, and maybe we could put it on some stickers or something. It might be cool. something like DevDocs, maybe. Looking for data viz Python libraries for front-end development. Because it's for front-end, I'd probably recommend using some JavaScript ones, to be 100% honest. But I guess if you're doing something like Django or something, but even still, you need JavaScript for any of that. But I can give you some good JavaScript ones for data viz. D3. It's funny because we're actually doing a spike on that for our project right now. We are doing a spike on some good data visualization plugins and tools. But yeah, get a USB stick and plant it in the back of your head like the Matrix. Not opposed. Not opposed at all. That might be the toolbox. Okay, so data is in a CSV and Excel files. Do you already know I need to parse the data between Excel docs and create the database? Do you already know how to there are packages for Python to there are Python CSV readers. Wow, why is this so? Yeah, which I actually think they have some stuff that's a part of the standard library, but there's also some external tools. Python's really good. I really love the Python packages for parsing out CSVs. Working with CSVs a lot better than like the ones for JavaScript. I don't know, it makes a little more sense, a little more comfortable. Yeah, you just got to import CSV and you can kind of work with it. You can open it up, you can read it, you can start to parse through some of that data. Yeah, parse through those fields and those rows and stuff. I actually have a big script that can give you a lot of the beginnings of that I may be able to send to you for that. Okay, so let's over on Exorcism. You get here on Exorcism and you log in, you load it up, and you're presented probably with a number of screens before this, but then you get hit with all of these things right here. You get hit with language tracks. Now, Exorcism is a dope platform. It's completely free, as of right now at least, for you and whoever you'd like to run through coding challenges. And what they do is they have these language tracks. You can see they have Bash and C and C# and all this stuff. They have Go and they have so many programming languages. And it tells you how many exercises they have here. I think Go or Python might have the most. Python has 117 exercises, so you can head down to Python. I'm going to try some stuff in Rust, a bunch of different options. So really whatever you want to learn right now, you can use whichever one of these languages you want. And all the language track does is it's just a track of coding challenges for you to kind of go down, and a lot of them overlap in between languages. And you can join multiple language tracks. You don't need to just do one, but we can go ahead and hop into one, and I'm gonna hop right into the Python one right here. Just click on it. It'll tell you about, what it is. Now, the thing I like so much about this is that you can actually get mentor feedback from these for free. And so it takes a little bit of time. It's not immediate, but a real person will go through and will take a look at your problem, take a look at your answer, and give you feedback on what you did great, what you could improve upon, what you can do differently to properly solve the problem if you were unable to solve it. And so all you do is you just click join the track, whatever track you want to join. And it's pretty dope. Now they are working on a version 3 right now. This is version 2 of Exorcism. They're working on the 3rd version, so they've already stated for the next couple months that because mentors are actually building this thing, it's kind of community driven, that response from the mentors will be a little bit slow, a little bit slower than usual. So it might take a little bit longer than usual for you to get what you need, but once you're on here, I would choose, so mentored mode will allow you to take a structured approach to kind of go through these problems, and maybe let's start with mentored mode. Practice mode will allow you to choose whichever problems you want at will, which is completely fine. You can switch between these two things at will. So let's go to mentored mode first. So if you're going in here, go to mentored mode, and again, mentored mode, it'll walk you through a progression of challenges, all 117 challenges, and in a little bit I'll show you how these things work. But first, a lot has just happened, so let me catch up on what's going on right now. One, thank you Logitestus welcome to the channel. Thank you for the follow. What's up, leading lady? I like the name. Welcome, Code Spin. Welcome, Webfu. Welcome, Jets Machine. Welcome. Oh no, hosted with one viewer. Thank you so much for the host. Thank you so much, Jets Machine. And Rhinogs7. Thank you for gifting that sub. I really appreciate it. Much love to you all. What's up, gamers? I am a gamer. I'm getting pretty good at Valorant. If any Valorant players are out there, I am in fact a gamer. What's up, Richard Hurst? How you doing? Tonight we're just doing a little bit of algorithms for the first time. So this is what it looks like in mentored mode. You're sitting here with a bunch of stuff in front of you, and you've got something available, and then you've got some things that are locked. It says these are locked here. So mentored mode will in fact keep you from doing coding challenges, and like until you've done the ones before them, you can't kind of move on. So it can be kind of it can be good, but it can also be quite frustrating, to be honest. But I think it is something good to do. Especially when you're first starting out. I think the progression is pretty good. I think it's pretty good. But if you want to switch, all you got to do is scroll down over here on the right and click switch to practice mode. And if you do that, switch to practice mode. If you switch to practice mode, you do not get the same access to mentored answers. So you can request someone take a look at your code. But you have to explicitly request it, and I think you only get a certain amount. But this way you can see all of the coding challenges whenever you want. You can see their difficulties, and you can filter them, by difficulty, and you can filter by topic. So if you want to learn, different things, control flow versus arrays versus booleans, you can kind of choose those different things if you want, as well as the difficulty over here. So it's kind of nice this way as well. So this is practice mode. So yeah, Wolfgang, thank you so much for the 300 bits. Thank you so much. You did mention thanks for the stream. I appreciate you. Absolutely. We're all here to learn. I'm learning with you. I actually am very excited about this 100 days of code, because like I said, I'm trying to learn some Rust, and I told you that I'm trying to become a better software developer. My goal over the years has been infrastructure and automation, but I'm really trying to become a much better software developer, because I think it'll help me be a much more well-rounded engineer. And I'm pretty excited about it. So, we're all here just learning together. Missed a few classes, busy catching up. Can't wait to be back. Hey, it's okay. It's not a big deal. Not a big deal. They should. So I did render out everything. It did finish this morning because I rendered out over 25 hours of content, and tonight I will be uploading. I didn't have time to upload them today because I'm going to be uploading like 35-40 gigs of video to YouTube. So those will be updated from last week. I also rendered out everything up to this point today, so partial stuff will go up tonight. This week will partially go up tonight. So all right, so this is what you got, and they give you a bunch of coding challenges, and these coding challenges, they're algorithms. They're algorithmic problems, and they basically give you a scenario, and you have to use algorithms to define a process to be able to get the desired output or answer. And again, some of them are very simple, some of them are very, very difficult. So we'll start here and kind of go through that. But some other websites you could use for this are coding. I'm going to share these real quick. Coding Kata, and I'll also put these in the Google Classroom right now. Coding Kata. So there's Code Wars. There's actual Code Kata. There's LeetCode. This is not what I was expecting. That's a cat. That's Coding Kata. I thought there was an actual just Coding Kata website. Maybe I'm thinking of Code Wars. There's LeetCode. There's HackerRank. I think you can make money on HackerRank, I believe. Not 100% sure. Code Wars is the kind of site. Okay, yeah. Code Wars, LeetCode, HackerRank. I'll share these in a second, but they are also good programs for this as well. The only reason I didn't go with these immediately is, one, you do the stuff. Most of them give you editors to do them on right there, which is great. I think that's great, but I actually subscribe to the belief that a lot of people say, hey, go with that. Same way people say, hop in to REPL.it, and I agree. I think those tools are great. but I do want you to start to understand like the connection between your computer and your editor and your files and how to run this stuff, like how you actually are running the code and things like that. So I like Exorcism because it puts it on your machine as if you were going to be, you know, really developing this stuff. And I think that I think it helps provide some more context around how to do some of this stuff in a safe way. Like I said, I've worked with people. Well, I've run into people who have pretty good coding skills, but didn't really understand like how to like properly run code from a computer and didn't have any command line skills. So like when they got to actually trying to build something rather than solving coding challenges, because they are two different skills, like being able to solve these coding challenges does not mean you're going to be able to build, you know, good applications. It just doesn't. But the skills that you would learn to do these could lend themselves for you to be able to do that. But they do not. They don't equally transfer. And I want you to kind of be well-rounded on that front as well. So I do recommend these sites. I do think they're good. Code Wars in particular, because I think the progression there is a little bit less intimidating. But again, I want you to know how to run this stuff manually as well. So Exorcism, let's head back over there. Let's close some of these. I didn't mean to close that. I think that's the one that I wanted. We're in the Python track now. There is there's a command line tool in which this uses for you to submit code and to interact with it, and it takes a few steps. So I'm going to click into Hello World and I'll show you where it is and how you can find out how to do it. Don't sweat it right now. I'll push this up to GitHub real quick so that you can pull it down and you can practice this. Oh yes, Advent of Code. I said that I was going to do Advent of Code this year. Doesn't it run only certain times, or is it just a series of coding challenges? Yeah, where's Advent of Code 2020? That was 2019. I guess you can always go back and do the other ones. But yeah, it's like, 25 days of code. Oh, it always runs in December. Oh, okay. All right. Oh, yes. Obviously, Advent of Code. That makes perfect sense. 100%. Sometimes you read things and you don't really process. That makes perfect sense, actually. But yeah, I can run through these. Advent of Code is, I know last year, I saw people kind of running through these. And I thought it was pretty cool, and I kind of want to try. Something like that this year. I actually want to try out some like problem solving competitions this year. I know there's some like coding challenge competitions that happen. I kind of want to just, it's uncomfortable for me, but I think it'll be fun to kind of try it out yet. But yeah, that's pretty cool. All right, so over here on the right, the way that Exorcism will break down these things for you is it will give you the problem over here on the left, and you can read through. So you can read through it before you try to solve it. You can read through, figure out what you want to do, and it will, it'll have all the things in there that you need. But see over here, they have this download. You need to have something, you need to have the Exorcism tool installed, and they'll tell you how to do it here. Now, this is easy if you are on Windows. I think it's just an executable and it's fine. Linux, if you're on Linux, I probably assume that you know enough to follow along. They give you all the commands and stuff that you need. And Mac, I don't know if they give you a downloader or not, but it says, hey, you can use a homebrew package. So to do that, and it kind of walks you through to let you know, hey, are you comfortable doing this? Are you not? And if you're not, it'll tell you exactly what to do. So it will give you a good walkthrough. So if you want to try that right now, I'll give a few minutes to allow you to go through the things over on the right to try to get set up and installed. It is, like I said, it already looks like they've done a good job of giving you everything that you need, like a good walkthrough. Oh yeah, they've definitely updated this since the last time I looked at it. Let me see if I already have it installed. I should actually. Okay, I already have it installed. First things first, I need to get my other, what's that thing called? I need to get my proper terminal stuff set up real fast, real quick, because I don't like this. Do I have config files in here? CD mastermind, CD config files, git pull. I'm going to move. Am I using NeoVim or regular Vim on here? Darn it. It's not gonna tell me which Vim. Okay, he's a Vim. I'm just using Vim, so I'm gonna copy .vimrc to tilde, and I'm gonna copy .zshrc to tilde as well. I'm not sure I have what I need there, but we're gonna find out right now. Ooh, look at that. That's broken. I broke it all. What is Snap? Snap is a package manager for Linux. I don't really love it, but it's a package manager for Linux. So if you're using Ubuntu 20.04, it's already on there, or you can install it. I think it's sudo apt install snapd. If you want to check out what Snap is, go to snapcraft.io. Let's see, I'll share it with you. And it's a package manager. Yeah, I don't love it, but it helps you install Linux packages easy. So you can check that out if you'd like. But yeah, it has a homebrew thing. So if you're on Mac, homebrew is probably the way to go, to be 100% honest. Okay. What do I need to download? I need to download Pure Prompt real quick, because you gotta look good to feel good. I truly believe that. And using npm, I think I just want to do it like this, because I think I already have everything else in my ZSHRC that I need. So I think I just want to run this, and I think after that I could have just reset it. Come on, yeah, I did it. I got my little prompt there. What happens if I cd into documents? Cd. Oh, okay, I need one more thing though. I need ZSH color, ZSH command completion. I think that's what I want. I want the colors. Debian. I could just do. I think I could just do it here. Yeah, take a little bit of time. Try to install it real quick. Try to run through what they tell you to do. Try to get it installed. I think it'll help. Hold on. What is this package called? Best ZSH plugins. I'm new to the ZSH world, so Snap is not supported by WSL. RIP. Are you on WSL 1 or 2? That's just for my own knowledge. It might be supported by WSL 2, which is kind of new. Syntax highlighting, that's what I want. I want ZSH syntax highlighting. So actually, real quick update. First off, I'm well aware nowadays that I'm trying to do too many things at once, but originally a while ago, actually, people have asked me so much about how to how do I set up my terminal this way? What terminal are you using? How do I get this stuff set up? I started out making a how-to guide on doing that. What it's turned into though is like an ultimate how to configure development environments, how to configure terminals thing. It's becoming a huge project, and so I'm just rolling with it now. It's probably because I'm going to be doing it for all platforms, it's probably going to be a solid 25-minute video. I'll put in timestamps for it, but just let you know something I've been working on. It'll come out eventually, like everything else. One day I'll be doing this full time and I'll have time to do things in a timely manner, but it'll get there. It'll definitely get there. I think all I have to do to install this is run a simple sudo apt install command. Let me move this out the way. Let's head over to this install.md. And yeah, I think I can just do this. And then I'll get some sweet syntax highlighting for my terminal. Sudo apt install. Do you have a need for business dev people? Probably. Who knows what I have a need for? Yeah, I mean, hey, maybe reach out. I don't know. Sure, I'm always down for business reset. And so now if I type in cd, oh no, I didn't like that. I don't like this. It didn't do what I wanted it to do. Oh, I needed to do, maybe I need to clone this to my ZSHRC. Maybe I need to run this, but let's open up one and see if it works. This is not System 76. I love your laptops, I really do, but the trackpad on this Galago is not amazing at all. It's all good. Let's see what we got. CD. Oh, okay, that's fine. I'll fix that later. Oh, I should probably pull that for everyone who has copied my ZSHRC. You're not gonna have these things. No big deal. Now I'm gonna get out of here. And then source it. Okay, don't need to source it if I just restart. And now if I see, yeah, now some colors. Yeah, there we go. Everything's beautiful now. Okay, I've given you a little bit of time. One, you saw me just mess about. And I'm giving you a little time to try to install Exorcism. If it didn't work, no big deal. Like I said, I'm gonna put this, I'll download these real quick and put them straight into GitHub so that you can grab what we're using without being able to do that. So here's what we'll do. We're gonna go into deCoded class examples, and in here I'm gonna make a directory for Exorcism. I'm gonna go in there, and this is where I'm gonna put everything at, even though it's going to put them somewhere else for me. And what I'm gonna do really quick is I'm going to go over to Exorcism again, and the way that you download this, once you have the command line installed, the way that you get some stuff in there is you just copy this download thing here and you run it. And I think I can give this a different place. I think I can make it download here, but it's gonna download it somewhere else for me. And so see, it downloaded it to this directory. It has a default directory that it downloads to, and then you can just go here, you can just cd over to this place, and the files would be there. But I'm gonna copy those here, copy -r. I'll copy that right here. So now we have a hello world directory here, and what I'll do is I don't need to do this, but git add Exorcism, and I didn't add functions from last time. I'll add them both. Added functions and Exorcism problems folders. All right, so now if you all want to grab, if you don't want to have to, set up your Exorcism command line, you can simply go to, now it's git example and not, I need to clean up these repositories real bad. deCoded class examples, you can in fact clone this repository, git clone this repo right here, if you want to grab it and you don't want to set up the Exorcism command line. All right, now Exorcism is interesting. There is another level of things that you're gonna have to learn to to help you solve these problems. And so let's go into Exorcism real quick and take a look at what they give you. So in the Hello World program or challenge that we have, take a look at what we have here. We have 1, 2, we have 4 files and a folder for Python in particular. But really what matters is right now there's a hello world.py. So they actually give you, usually they give you the files that you're going to need to start working out of. And again, this is why I kind of like this, because when you work with these other tools, you don't get this much context. Now it can be confusing, but you don't get this much context. And so there's basically what they give you is they give you the file to work out of, which is actually this hello world.py. I'll show you what it looks like. They also give you this test.py. They give you the readme, so readme.md. Whenever you see readme, that's going to be a file. It's a markdown file that exists within the repository to give you information about either how to run the program or what's going on. So if you are using VS Code, for markdown files, so if I open up this readme.markdown file, it shows like this, and I can go through and read it. You know, it's great. But markdown is a way of structuring. It's a way to structure text. It's a way to structure things on a page. You can click this little preview pane right here, and it will actually open it up with all the proper formatting. So I'll show you what that is one more time. Just make sure it's open, and right here you can click this open preview pane, and now this has all of the formatting that you would expect. It's the same file, but it's just showing all the formatting. So this markdown file, this will be the exact same thing that is right here, that is on the page. So where were we? Gotta find it. Oh, right here. So whatever you see right here, the markdown file is going to be the same thing. Exact same thing. So you can go here to see it, and it's going to explain what the problem is. So let's read. Let's practice comprehending what it is that they want us to do. So it says, this classical introductory exercise, just say hello world. Hello world is the traditional first program for beginning programmers in a new language environment. The objectives are simple. Again, read, comprehend, understand what they're asking of you. Don't assume. These are the objectives they're giving us to us right here. Write a function. So now we're pulling those tools already out of the toolbox. I say write a function. That's basically like, hey, grab the screw. And you reach in that toolbox and grab what you need. So write a function that returns the string hello world. Now it does say run the test suite and make sure it succeeds. We'll talk about that in a second. Submit your solution and check it at the website. Okay. I did put inside of the Google Classroom, there's a video that's an introduction to something called test-driven development. You haven't learned about this yet, and it is okay. We actually have an entire class doing and practicing test-driven development. Hold on real quick. Let's get logged into here because I don't know when it is. Copy password. But I want to say it's a little close. Now you guys know my password. Now I got to change it. Not a big deal. I don't know why I pasted it like that, but it's all good. I'll change it real quick. I should just turn on two-factor auth as well. Now I got to change it right now because while I trust most of you, you know, I don't want to get locked out of my own thing. Give me 1 second for making that mistake. Really quick, I'll just switch it up. Changing right now. Let's generate a fancy one. Generate secure password. Fill it. All right, there we go. I'm updated. I'm safe now. I am safe. All that just to get into Notion. Yeah, but 1 second. Let me go to curriculums. I could just show you where when we're learning TDD. Tonight we are at the, I know it's tiny. Oh, you actually can't see it. Right now we're learning the intro. We're on intro to algorithms. So 1, 2, 3, 4 classes from now, we'll be learning TDD, something called test-driven development, and learning actually how to do that. You missed my password. Well, it's changed now. So if you want it, I can send it to you if you would like my old password. It was, it's not something that I reuse. I use LastPass to create my passwords. So, I'm relatively safe out here on the internet. I'm pretty good. You underestimate my power. No, I do not underestimate your power at all. Good security practice rule: do not share your password with anyone. For 100%. Show us your new password. I'm sorry. I will do my best not to show you my new password. Yeah, it's okay. You don't need to know my password. My password for my LastPass is a long password that I memorized myself. So that password is secure. My master password is 24 characters that I memorized on my own, because I'm, basically photographic memory, just sometimes I surprise myself. But yeah, it's 24 characters, and I memorized it. Okay. What were we doing? Okay, I gave you the hello world. We were reading through hello world, and not all this stuff. We're talking about TDD a little bit. And why were we talking about TDD? Because right here it says run the test suite to make sure that it succeeds. Now, you do not need to do this to solve the coding challenge, but when you don't need to do it to be able to practice the coding or do the coding challenge. The problem is the tests that they have. So first, real quick, test-driven development is a practice in which you write something called tests to test the functionality of your code, but you actually write these tests before you actually write any code to solve the problem. And you might say, how the heck does that happen? How can you test code that doesn't exist? Well, your goal is you read the problem, you write tests that confirm the problem, like confirm the solution to the problem, and then you write your code to make those tests pass. And so it's an interesting one. We'll talk more about how effective it actually is and the process of it. But yeah, we'll talk about that a little bit more. But they do provide you tests, so they write the tests for you, and these really do. The reason why I like this so much is going to take you the learning curve to get into it's going to be a little tough, but having these tests available to you will make it way easier to solve harder problems because they're going to give you scenarios which you need to solve. Now it takes time to understand how to read these tests, all that stuff, but again, you're just getting introduced to all the stuff right now. All you need to do right now is only worry about what the problem is. So write a function that returns the string hello world. That's all we want to do with this one. Not necessarily, we don't really care if we're all the way right, and let's just see if we can solve the problem that it says. So hello world.py is the file that we're going to be using to do this. They give it to you already, and hello world test.py is actually those tests. So this is code that's going to test what we're going to do. Again, I wouldn't stress about that too much right now. I'm going to introduce it to you. I'm going to run these tests, but don't sweat it right now. Hello world.py. So look at this. They give you some stub code. So that's what this is called. It's called stub code. Stub code is basically like structured code that people give you to kind of start the problem solving workflow that doesn't have complete logic in it. So right here, let's take a look at what they've given us. I did not teach you about this keyword, but that's fine. You know that def, we just learned about this. So def is how you start a function definition inside of Python. So they're setting up a function for us called hello, and it does have open and close parentheses. So this is a function they've given us. Now, this is valid code. The reason the pass is here is to make it valid. A function has to have something in it. And the pass keyword just says, hey, just, it's just pass, keep going. And so that makes this valid. So basically this is code that's an actual function that will do something, like it'll actually run, but it doesn't do anything. But it will in fact run. The pass keyword allows it to run. But they want us to, again, comprehend here. They want us to write a function that returns the string hello world. So first thing we gotta do is write a function, and it looks like they've already given us a function. So all we have to do now is we have to return hello world. Okay, we need the function to return hello world. Returns the string hello world. Start breaking it down into the things that we've learned. String, you know what a string is. You know a string is words or phrases. You know a string of characters, and you know you should be thinking about quotes. You know how to make a string, and we just need to return that. So you can do this in 25 different ways, but read the word. It says return the string hello world. This is not a problem that says print hello world. So you might get into this and you might do something like this. You might say print hello world. You might assume and you might think this is what you're supposed to do. And so we can do this and we can save this and we could run the code real quick, and nothing would happen. Why wouldn't anything happen? Well, I should have done it like that because it looks like something happened, but it didn't. Nothing happened because remember, what do we learn about functions? We learned that functions do not run unless they are called. So we're not calling this function. And you might go down here and you might say, all right, I'm going to call this function. You know, I have a function that prints out hello world. I'll call it down here. The Spotify command does not work, but if you want the playlist link, it is right. Yeah, copy playlist link, paste it in. This exact song is called Celestial Reverb on that playlist. If you're looking for that. And so if we do this and we run it again, it will in fact do what we want it to do. Great. Prints out hello world right here. Nice. Okay. Now again, is that what the problem said? Not really. And how would you know that? How would you know that for sure? You might assume that that's what they want you to do. Print hello world. They did not say that. They said they want you to write a function that returns the string hello world. And so again, you can start thinking, but the way that we could confirm that is that's what the tests are for. The tests help guide us to know what to do. And so we're going to look at this test. This is not a part of the algorithmic problem solving. This is just me introducing you to a kind of new programming concept. So don't stress yourself out about this piece. Tests are hard to read. I think tests are hard to read up front. But what happens here, you don't know about classes and all this stuff yet, but all tests do, at least the tests they're going to give you, is going to be setting up a scenario that says, hey, if I have this input, I expect this output. And that's how you can determine whether or not your code does certain things. And so we have this function here that says test say hi. Don't worry about the self, but it says self.assert equal. And it's basically saying, hey, when I run this thing, when I run hello, all you got to do is look here. So when we get farther along, you'll see I want you to ignore everything else in this file. Everything else in this file. What you're going to see here on this assert equal line is going to be when I run hello, I expect to get this output. Whenever I do this thing right here, I expect this thing to happen. And that's essentially what the test is testing. It's saying, hey, when I do this, I expect this. And so right now, if I were to run this test, they tell you how to run the test in here. They tell you how to run it somewhere in here. To run it, you run pytest hello world test.py. Now you're probably gonna have to install pytest. I don't think it's installed by default. But if I paste that in, it does run and it gives me a big fat red error. And it says F here, it says it failed. So why does it fail? It's hard to read these things as well, but the assertion error is that none is not equal. You've seen this before. Exclamation point plus equal is not equal to hello world. It's not equal to hello world. And so basically it's telling you that what we got back from this is none. None is what you got back. And on this side is what it should have been. So remember, hello world is what we should have gotten back. But we got none. Why do we get none? This function is supposed to return the string hello world. And does this function do that at all? It does not. It prints the string hello world. So what do we learn about returns? We can just use the return keyword. Return hello world. And we don't even need to run, we actually don't even need to run the function here. It says, hey, the function just needs to return the string hello world. So we do exactly what it says. Return hello world. I'll save this and I'll run that test again. And when I run it again, it fails again. We get a lot of different output. And now look what it says. It says this on the left, it says hello world is not equal to hello world. And you might say, what? And look at it. It's doing a string. It's comparing two strings. And this hello world is not the same as this hello world. And it shows you what's different here. The comma is missing and the exclamation point is missing. So I did not do exactly what they said, and I need to go in and I need to fix some things. I need to add the comma. I need to add the exclamation point, and I can try this again. And now it passes. Now it's green. Now, that seems like a lot. Yes, it did seem like a lot. But again, this is why those tests are good. The test, having the test up front, help you know exactly what the implementation should be. It said just write hello world. So I wrote hello world, and I did my best to solve it. And yes, what I did what it was supposed to do, but it wasn't exactly what they were looking for. And so I don't think you necessarily need to know this stuff to be able to solve the problems. I think right now, until we get there, until you get comfortable with it, download the problems, read through them, solve them in the way that you want, and upload them. I think that's completely fine. You do not need to be perfect. You do not need to be right. I think there's a lot of value in doing that. I think share with the community, share with each other. I think there's some value in that. But I just want to show you how these tests can be used to show you exactly what the implementation is supposed to be. And it's very good. So yeah, if yours says okay, you're good. You're good to go here. But we've solved our first problem. We got it to be green. Once you have the test passing, you've solved the first problem. And the way that you submit it is from your terminal. You type in exorcism-s and the name of the file that you worked out of. So we worked at a helloworld.py. Oh, actually, it usually won't let you do that. It's exorcism submit. And it tells you how to do this. I'm not in the workspace. It won't let me do it because I'm in a different workspace. But don't sweat it. I'm not gonna submit this right now, not a big deal. I'll push it up to GitHub really quick. But we're about to solve some more algorithmic problems. What's up, Dusk? Thank you so much for the sub. For the host. Really appreciate it. Thank you so much. But I just wanted to introduce you to the first one that we're gonna hit and what that looked like. Now, that was mostly everything we just talked about was an overview of exorcism and how to use it rather than the algorithmic things that we're going to be doing. So we're going to pick a harder problem, and then we're going to take the things that we learned. We're going to read the problem. We're going to break it down. We're going to write some pseudocode, and we're going to solve the problem. We're going to practice putting those things into action. So let's do exactly that. Let's grab one that's a bit harder than this one that we just did. Let's go back in to Python, and when you push your code here, it will show the code that you wrote, and it'll be sitting there. And actually, let me actually show you how to do that. It basically wouldn't let me do it because I'm not in the right workspace, so I need to go to where that is. I think it's in home/exorcism Python hello world vim. Exclamation point, same code, and exorcism submit, and the file that you worked on. And again, it tells you, if you don't remember how to submit, it tells you how to do it right here to solve your code. And then you can just copy this. You can copy this right here, and it will help you submit. And once you do, it'll basically give you a little thing that says, hey, your solution has been submitted successfully. You can take a look at it here. And so you can click on solution and show where it's uploaded to. So this is the code that we just wrote. And you can request mentor feedback, or you can complete it. So I'm going to complete the solution. And once you complete it, you can go look at other people's answer to the problem. So this is another reason why I love this, is because you don't need to answer it successfully. You just need to say, hey, I tried. You can submit. And then once you do that, you can go in and view community solutions. So if you have no idea how to solve the problem, you can put up just anything. You can re-upload the same code that was downloaded. And then you can go in and you can see how other people did it. And that is a huge thing. It's a when you get to the harder problems, any problem besides hello world, honestly, it's very valuable. Because even if you think through a problem, let's say you grab a new problem, you think through the problem for 10 or 15 minutes, 20 minutes, you make zero progress. But I'm telling you, the mental gymnastics of thinking through that, because like all you're doing is reinforcing the tools that you've learned, and you're thinking like, okay, I see a string, I see this, and you may never get anywhere really, but you've thought through a bunch of things. When you have thought through it yourself first, or done your best to think through it first, and then you take a look at a real solution and start to mentally try to work through the solution and what the person did, it puts into context so many things, and it really, really does help. I know a lot of people are scared to do that. People think you're cheating if you do that. Not at all. You should try, but these things are hard to do. It takes time to be able to get up to be able to solve these things, and submit your code, say, I gave it my all. Even if the code is terrible, it doesn't work at all, whatever, submit it, no big deal. View a community solution, take a look, and just see what other people tried. People's codes are going to be different. See what they tried, see what worked for people. Copy their code, try to run it, see what happens. Try to modify it and see what changes, see if they can help you understand what happened. Change certain things in there to see if you can get different outputs. Things like that is super duper helpful. And that's another reason why I like this platform, is because you can see other people's code immediately. All right, so now let's go back and let's actually try one that's a little bit tougher. So hello world, to get you started, all good. All right. Oh, you got to set up. Perfect, Sean. You got to set up. There we go. You're in there. Ooh, hemming. I like hemming. Hemming's hard. Not hard, but the hemming one is like so I will say, do not feel bad that they put the term easy on these and you find them to be difficult. These all easies are not created the same. They only have 3 levels. Hello world is easy, sure, it's as easy as it kind of can get for a programming problem, but let's head over to this one, which is twofer, which I think is the simplest step up from hello world. I think some of these changed a little bit. Like I actually think hamming is a little weird. Like I don't think you would be able to just hop in and do that, but twofer. Let's do the linked list one in JavaScript. Not yet. We're gonna get there. We're gonna get to all of that stuff. We're gonna get there. Does my Prime subscription have to expire all the way to resub? If you subscribed using your what is the thing called? Amazon Prime, yes, it does. But if you got a commercial, garbage. Well, if you got a commercial, yeah, it should be expired. Yes, you do have to. If it's a tier 1 like paid sub, it can automatically do it if you set it up. Appreciate the support. I really do. Really appreciate you. So twofer, let's go. This one is a little more, raindrops is like FizzBuzz, so maybe we'll hop into that because we have some time. We got some time to kind of work through these, but let's take twofer. The pseudocode for this is probably already here. Like actually the pseudocode really is kind of already here, but we'll take this and we'll get going. So I'm going to download it and I'm going to upload it for you so that you can grab it in case you didn't get exorcism set up yet. But let's read through the problem real quick. Twofer, actually also, this is a community driven website. Some of the walkthroughs, some of the introductions are not written properly or with confusing language, and that's okay. That's why the tests are really great, but just try to bear with them. But I don't know if this one is like that or not. I just kind of let you know right up front. First off, I'm okay with either one. And you know, it's fine. It's fine. It's booze and hiss. I gotcha. That makes sense. Either way, didn't really care. I actually didn't even think of that. So, pretty interesting. But either way it's fine. You can all call me boo. You know, I'll call all of you boo. You're all my boos. Sorry if you're offended by that. You're my boo though. Everyone's my boo on here. Everyone's my, you know, whatever other term of endearment you would like. I'm in for all of it. Call me whatever. I'll respond accordingly. But yes, let's read through twofer real quick. Twofer, or twofer, same thing, is short for 2 for 1. 1 for you and 1 for me. Given a name, return a string with the message. One for X, one for me, where X is the given name. So where X is the given name. So this is kind of where your reading comprehension comes into play. I think some of these are, yes, it is. It's so hard already. And this is why you need to comprehend first. This is why comprehend, read it 10 times. It's okay. So start over. Twofer or twofer is short for 2 for 1. 1 for you and 1 for me. Given a name, return a string with the message, 1 for X and 1 for me, where X is actually the given name. So given a name, return a string with the message X, with the message, 1 for X, 1 for me, but X is actually the name that was given. Okay. That may be one broken down part, maybe, but we'll see if we can break it down in a second. However, if the name is missing, return the string, 1 for you and 1 for me. Ooh, this is intense. This is intense. Okay, 1 for you, 1 for me. Here are some examples. This is an example. Name, string to return. So if the name is Alice, it should return 1 for Alice, 1 for me. If the name is Bob, it should return 1 for Bob, 1 for me. If the name is Empty, it should return 1 for you, 1 for me. If the name is Zaphod, it should be 1 for Zaphod, 1 for me. Okay, great. Sean, there we go. So it could be, but yes, you're right on track. Name equals input. But let's break this one down. I'm gonna download it real quick, give it to you so that you can have it really fast. So let's copy this, copy -R, whoops, /home exorcism, A Brooks exorcism, Python twofer. Copy that here. Whoops. Move twofer. I messed this one up. Dot. Okay. I'm in the wrong place. I am in the wrong place. So it's gonna be move twofer. I need to move that to documents, mastermind, decoded class examples, exorcism. Okay, and CD /documents, mastermind, decoded class examples. Git add exorcism twofer. Added twofer coding challenge to exorcism. I really need to fix this piece. I'm tired of typing this in. All right, so if you already cloned this repo, all you have to do to get the updates is do a git pull. All you got to do is do a git pull. Make sure you're in this directory, make CD into that directory that you cloned, and do a git pull if you want to get those updates. Or you can delete the folder, reclone if that makes you feel any better. But now twofer should be up there. Hopefully I did not give you twofer with the answers, because I think that folder was already there. But yep, simply do that. So let's see. Let's start solving this problem. Let's start pseudocoding this out a little bit. So darn it, I need a way to put my whiteboard and some of this other stuff maybe side by side or something, but no big deal. We don't have that right now. So whiteboard it up and let's go. I will read the twofer stuff to you. Okay, given a name, return with a message. So maybe you would want to do something like this, and this is okay. I'm not going to try to do perfect pseudocode right up front. I want you to just approach it like this. It says, given a name, return a string with a message. So maybe you would start breaking it down like that. And you might say, hey, let's break it down. Actually, let's do number one. The first thing that we want to do, actually make this, let's actually delete this. And let's make this smaller. Maybe that's my problem. All right, cool. So given a name, one. Given a name, return a string. So we'll do that part here. Given name, return string. Maybe that's part one. Maybe that's the first part we're gonna try to break down and figure out. Ooh, go React. Thank you so much. I'm gonna make you VIP after this. Thank you so much for the gifted subs, the love. I do not the biggest React fan, but I'm a big Go fan, even though it says Go React. JavaScript's cool, you know, not a big, you know, React's kind of tough for me, but I really appreciate you. Thank you so much for the gifted subs. Everyone, please thank Go React, and I will VIP you if you're not already VIP. I feel like you're already VIP, but we will definitely VIP you if you're not already VIP as soon as we get through this. So maybe that's the first part. So give it a name, return a string with the message, and again, that message is going to be 1 for X, comma 1 for me. So maybe we'll try to solve that problem first. All right, and then the next thing we have is if there's no name, so no given name. There's no given name, return string. Return string, what's the string? 1 for you, comma 1 for me. Okay, so this is the problem. This is the problem broken down into two different into two different pieces. Given a name, return the string 1 for X, 1 for me, where X is that name. And if you're not given a name, return a string 1 for you, 1 for me. So we have the two different pieces, and now we can, well, we've broken it down into two pieces. Hopefully, maybe you can break it down into more, maybe not, but we'll break it down into that for right now. And then now you can start to write your pseudocode and see if you can highlight the solution for like number one. So given a name, return a string. And so I saw that Sean said, okay, maybe there's gonna be some input. So maybe you say, all right, you know, input, maybe you say something like this. Actually, maybe you say something like capture input to variable, because we know that you have to, if you're gonna take input, you have to capture it. So maybe we'll say capture input to variable, and then return variable, actually return 1 for variable, comma 1 for me. And now this isn't great, this is not great pseudocode, but I'm just letting you know how like vague and random you can start. You know, this is basically the plain English that we wrote up here, but I just indented it to be honest, and I used the return keyword because we know about the return keyword. And you can say, okay, you know, capture input variable, return 1 for variable, 1 for me. And then maybe you can write something like, all right, if there's no given name, return the string 1 for you, 1 for me. You can say maybe like check for input, if no input, return 1 for you. Man, I'm struggling over here with the writing. Oh, come on, there we go. 1 for 1 you, comma 1 me. Okay, this pseudocode. Okay, breaking it down, just having, you know, just breaking it down into some code like stuff with it. Now, this may not be right, and I'm telling you right now, this is not right, but well, not right not right in the structure of how we're going to end up solving this, but it's a way to get you started. It's a way to kind of start to help understand it. And when you write it out this way, you might start to see why it's wrong. So if you read through, all right, capture input variable, return one for variable, one for me. Now, if you go and do that, if you return that immediately, you know, we talked about how in a function, you can only have one return. It can return multiple values, but you can only have one return. But then we're checking for the input after that first return, and we say, hey, if no input, return one for you, one for me. And you might say, all right, that feels a little weird. So maybe the first thing I need to do is I can take the input variable, and then maybe I can then check if it's empty or not. And so maybe you want to start over, and you might want to say, all right, first thing I want to do is capture name, because that's what it says. It's gonna give you a name, give it a name. So capture name. Then maybe you want to check if name is empty. And then if you do, if we would check if name is empty, we can say if name exists, return, one for you, or one for name, comma, one for me. I'm struggling over here. One for me. But we've learned some of those conditional statements. We learned if, and if something's true, do this, else do something else. So then we can say maybe like else, if name doesn't exist, name does not exist, return the other string, return other string. And again, this is just a little bit of practice. Go around, try to write stuff out, just writing out the logic in mostly plain English, trying to use the things that the structure that is available to you in a coding language. So it might look something like that. Maybe it looks something like that. I will actually share all the pseudocode. I'd actually be interested to see all of your pseudocode as you try to work through something like this. All right, what comes after pseudocode? It comes the code. So we'll take this and let's try to apply it to some code, and let's see what happens. Let's see how to solve this. All right, yes, you can in fact force exorcism downloading your folder. I need to do the same thing. When I pulled down and created its own folder, yeah, it does that. You can rename it. There's a way to pass in the workspace folder that you want. I don't remember how to do it, and I didn't want to take up any time to do it. If you pass a folder path, oh yeah, yep, I can do it. Yes, actually, so let me see. Exorcism, if you can find out how to do it from here. So if you type in exorcism, what is it? Help. So actually, let me see what the commands are. Exorcism. How do you exorcism now? So if you do exorcism, download help, -- help. I think it'll tell you what to do. Download exercise string. Maybe, I just did that. I did -- help. Didn't give me that much. Maybe you have to do it. Let me try exorcism -- help. I know you can do it. Maybe you have to change your workspace folder. Workspace. I think this is it. I think you have to somehow change this, and I think you have to use the configure command to do that. But yeah. With the exorcism command, the way that you get it is you do exorcism download, and it actually tells you in exorcism, the way that you get it is right here. You download the files right here. So whatever one we're working on, find that one. We're working on Twofer, and it tells you right here on the right, and it will download. And actually, I think it'll I know it won't. But there's a way, I think, in the workspace to change where it downloads to. I do find that to be kind of annoying. Okay, let's get in here and let's start solving some problems. So let's head over to our folder, and I'll hop back into VS Code for this. You guys are making me do things I don't want to do, like use VS Code, even though it's a great product. Okay, so again, we can pull up the README so that we have the README available to us so that we can refer to it. And so I'll open it back. I'll open it up with the thing here. It tells us exactly what we're supposed to have. And so the hello world workflow, the hello world problem should have you already thinking, hey, I need to be paying attention to exactly what they're asking of me. You know, we forgot the comma, we forgot the exclamation point. So I need to be paying attention. I probably should copy and paste. So let's look at the files we have available to us. So they give us a twofer.py, and let's see what that looks like. That's the stub code. That stub code looks exactly the same. So they give us a function called twofer. Now take a look at what's different about the last one and this one. It takes the last one did not take any arguments. Hello world was just a raw function. This one already takes a name. They already set that up for us. So they help you out. They give you some of the stuff you may not know. And so it already takes a name, and now that should help you out. That should help you start thinking, hey, given a name. Okay, so we're given a name. So if we're being given a name, that probably is going to tell us a little bit of information that maybe we don't need to be asking for the name, because the name is going to be given. So we're just writing a function that the function takes the name, and then we are going to return some information. So given a name, return a string with the message, one for X, one for me. So let's start there. Let's start right there. Give it a name, return the string, one for X, one for me. So how do you return a string? The way that you return a string is you type in return. One for X, one for X, comma, one for me. And so we'll get that there first. Let's give it a name, return one for X, one for me, which is right here. And there's a comma in there. I probably should have copied and pasted. Oh no, I put the comma in there. Cool. But it says where X is the given name. So we'll change that. The way that we change that is we must, we know that we can put that in here, but what is the process called when you stick, when either you can do it one of two ways. You can stick strings together end to end, which has a name, or you can put the variable in the middle of here and have Python figure out what that variable is and automatically replace it at runtime. And we know there's a word for that as well. The first way that we can do this, again, is called where we add them together end to end. That's called one's called interpolation. This one is called concatenation. This is called string concatenation. So I could go like this: one for name, comma, one for me. That's one way we can concatenate the strings. We can add the strings together end to end. But I think for this, it'll be a little bit better and a little bit cleaner. I prefer to interpolate strings rather than concatenate. And interpolation is where we stick it in the middle and we say one for name, comma, one for me. And we'll put a little F right here. I actually don't know if this works with returns. Maybe it does, maybe it doesn't. I'm not sure. One for, and maybe I don't even need to put the F there, but we can test it out. So we can test this out ourselves before we run the tests. The tests are great. You can use the tests to determine if you're right, but we can also just run the function ourselves. So we know how to run a function. We know that to run a function, you must call it. So I'm gonna call twofer, and I'm gonna pass in a name. I have to, if it says it takes one argument, one parameter, that means I have to pass it one parameter. I'll pass it a name really quick. I'll pass it Sean, and we'll run this and we'll see what happens. So we're gonna run Python 3. What is this file called? twofer.py. And we run it, nothing happens. Why does anything happen? Because we didn't tell it to do anything. It ran, it gave us no errors. We are returning this string. We are not printing out this string at all. We are returning it. We're not printing it. Again, just returning it, it still allows us to do some things with it with the test. Returning is good. But if we want to actually see what it is, I think we can just print it like this. I can actually print us running that function. And now it should print something out for us. So I'll rerun that. And it says 1 for Sean, 1 for me. So that looks pretty good. That looks like we're doing what we want to do. And so I'll actually put a little space here, like we're supposed to have. And it looks like it's doing what it's supposed to do. And let's look at the test really quick. Just to get a little practice in. Again, I said ignore everything else in the file. There's a lot of stuff in the file, but look for these little lines here that say self data. Look for the word equal, basically. And inside of the parentheses there, it'll say, hey, when I run twofer by itself, when I just run twofer, I expect this output. And when I run twofer with this input, I expect this output. And when I run twofer with this input, I expect this output. So what you can start to do is you can start to code to that. You can even start to try to do this and see. So they're running twofer with Alice. Let's see what happens when we do twofer with Alice. What is the output supposed to be? It says 1 for Alice, 1 for me. And we can check to see if that looks like the output that they expect in the test. And what they expect is 1 for Alice, 1 for me. You might say, oh, that's pretty good. So it basically just is going to run your function with different inputs and expect a different output. And so we can run our test here, test against this. Again, you don't need to memorize what it is to run the test. It tells you in here how to run the test. And it says run PyTest, twofer test.py. And so I'm gonna run this real quick. Actually, I'm gonna remove the extra code. That's okay. It's okay. Navadino, it's okay. You're not gonna need to do that. I mean, no, if you need to, you should. But don't, like, if you're struggling to understand right now, it's okay. We're gonna just stay with us. We'll keep moving forward. Again, there's a lot going on right now. Don't sweat it. We're gonna get into the 100 days of code. I'll be giving you some stuff. You'll be figuring out some things. Missing the dot at the end. Excellent. Okay, so let me first, let's run the test really quick. So PyTest, actually, I'll just paste what I copied and it'll run through. And now we have some errors. Again, hard to parse, but I have 3 failing tests. Now look at that. There are 3 Fs here. Remember, in here, there are actually 3 different tests. There was 1, 2, and 3. 3 different tests. They all failed. And we can see why. 1 for Alice, 1 for me. Does not equal 1 for Alice, 1 for me. I capitalized the O. And I think that's the problem. And it tells me right here, yep, capitalized O. So I will make this a small O. Save it. And run this again. And check this out now. I have 2 passing tests that turn into little green dots, but I only have 1 failure, and it tells me what happens here. So when it ran just twofer alone, it's supposed to get this output, but it actually failed to run because our function says, hey, you must in fact take an argument. There are a couple different ways to solve this problem though, but it says missing 1 required an argument position name. So it says that it's telling us that, hey, you didn't solve for this problem. So let's read through what the problem says again. We solved for one thing. So we solved number 1. We said when a name is given, return 1 for X, 1 for me, where X is the given name. However, if the name is missing, return the string 1 for you, 1 for me. All right. The way that you can do this is there's a couple different ways that you can do this. Actually, this is actually a tough one for beginners. This is actually a pretty tough one for beginners. This is a tough one for me. Why is it a tough one? I'll show you in a second. It seems like a lot of people are giving answers, and I think that sounds right. But let's try that. Actually, let's just do the right thing first, and we'll say, hey, use an if-else statement, use an if statement. So an if statement allows us to, check for something to be true or false, and make a decision based on that. So we can do that. So how do we check if something, what are some ways that we can check what are some ways we can check if something exists or not? You may not know this yet. Well, you don't know this yet. And so what you could do during this is say, hey, I'm gonna check if name is empty. Because we learned about empty values in different programming languages. We know that for a string, the empty value of a string is just this. So you may want to do that. You may want to say, hey, check, say if name is empty. Whoa, that's not what I meant to do. If name is empty is equal to you know, an empty string, go ahead and we need to return 1 for you, comma 1 for me. But if not, maybe we want to say else return what we had. Now this may be a way to check if it's empty. And if we were to run this, let's actually run this real quick. It's going to show us a problem really quickly. So we're gonna say, hey, if name is completely empty, if name, you know, is an empty string, go ahead and print out 1 for you and 1 for me, or else do what we did before. And so we can practice this ourselves, and we can type in twofer, and we could not pass in anything. And we're gonna run into a problem immediately. Python 3 twofer.py. And I actually think this is a bad beginner problem. I think it's a very bad beginner problem with the tests in particular, because it says twofer, missing 1 required positional argument. Again, if you go back to the slides last time, what it says is if a function says it needs an argument, you must require the exact number of arguments that it says. And so that gets interesting. That gets interesting. And so maybe it's not a bad beginner problem. Maybe I just did not teach you the right things for this. But here's the problem. The test that they are running is without a name at all. No given name. With no given name at all. And so because the function needs a parameter and needs an argument to run, what can we do? And so this is a Python, there's a paradigm in Python in which you can do is you can actually set the default value for a variable that you're expecting as an argument. And what you can do is I can actually set name equal to something by default. And so basically what will happen is, it will only use this if nothing is passed in. So I can say, you know, name equals empty string if nothing is passed in. So it'll default to empty string. And if I run this now, it does not fail. Before it would fail. This time it did not fail. It did not give us this missing 1 required argument, and it didn't. Again, this is a Python specific paradigm, but other languages aren't going to run into this exact thing because the tests are actually going to be different. I'll show you with Go in a second. I'll download twofer with Go and show you how different the tests are and what they have to pass in depending on the language. So this is testing your knowledge of Python. And so I actually think that if you were someone brand new trying this, what would end up happening is you would run through and you would probably be super close, and you would probably never be able to solve for that empty case because you would never be able to get it to run. Or you would be smart and you would go in here and say, hey, I'm gonna just change the whole test because I need something. So in the test, I'm gonna put, you know, an empty string. I'm gonna pass an empty string. But what you would do is you would just submit it, and you would go into the things and you would see people's answers, and you would say, oh, I didn't know you could do this. And maybe you'd be like, what are they doing? What is that? And maybe you start doing a little bit of Googling, and you would start to, you know, come across some answers. So it would be a little bit of some uncomfortable self-discovery. But as long as you pass a value in for name, it'll get overwritten, but the default value will be this. There are a number of other ways to do this. Another way that you can check for strings and things to check if strings are, you know, non-empty is I could say, hey, if name, I actually don't remember in Python, is it length? Or is it len? I never remember which it is. Is it len? Is this it? Yeah, I could do if length of name is 0, or less than 1 is less than 1. If it's less than 1, that means it's got to be 0, because you know the amount of characters. If it's less than 1, that means it's an empty string. And I can say if it's less than 1, then go ahead and do this, and this empty string would make it that. And so I'll say less than 1, and I can run it again, and it would still work. It doesn't print anything out, but it still does in fact work. And I can print this to actually see what it returns. And let's run that again. And it says 1 for you, 1 for me. And so that's great. It's great that it says that, because we know that it matches this thing. If it printed out 1 for you, 1 for me, that means this statement right here returned true. It means that it returned true. What's up, M Rahulk 11? Welcome to the channel. What's up, Animus Glitch? Welcome to the channel. Thank you for the follow. What's up, Actual Tom? Thank you so much for the raid. I'm sorry, Actual Tom, I missed it. I was zoned in. Welcome again, Actual Tom. You've been super kind this week, bringing your people over here. I'm not sure why you would bring them over here, but welcome, Actual Tom's party. The Actual Toms, you know, we have the Cyber Barbies and we have the Actual Toms. That's your group that I'm, you know, that makes sense. Welcome to the channel. Welcome. Today we are just learning how to, you know, solve some algorithmic problems. Yes, we man, the cadence, we're getting ready. I need to make some type of interactive raid thing like every other cool channel out there, but you know, one step at a time. Does Python have a null? I don't know, actually. I think Python is none type. I think Python has none type. I think it's I think this is none type. I don't think it has null, to be honest. But yeah, you may be able to do, I don't know if you can do this in Python. In some languages you can do, well, this would actually be false. Like I think you could do like if name, but the problem is we've given name a value, so this would actually always return to false. So watch this. I do this right here. If this works, if you can do this in Python, which I don't know, it's gonna end up using this one. And let's see what happens. It's basically gonna print out a weird string. See, it did use that one. It says 1 for blank, 1 for me. I ended up using that second one. So you can do that. You can use that. You can use this paradigm to check for the existence of something. But that won't work for this function because I guess I see what you're saying. I guess you can check, you can set it to none, and this will work. I guess that's weird. Not weird, but no, it won't. So none type is not the same as interesting. That's interesting. I learned something here. I learned something. So none type is seen as an existing thing. That's very interesting. Very interesting. I learned something else. Okay, that's fine. We'll leave it how we had it. If name equals empty string, go ahead and do that. And so this is one way to do it. There are like 8 other ways to properly do this. So another thing one thing I would like to teach you all is this. You do not need this else statement. And you might be saying, hey, why don't you need that else statement? You know, if this, do this, or else do this. Because you do not need this else statement, because remember, once we return, you can only have one return. Once that return runs, it drops out. This function is over. Once it hits a return, once it actually runs a return, the function's done with. So what you can do is you can remove that else, and you can just have this down here. So why can you just have it down here? Because basically it'll evaluate this if statement. If it's true, it'll run this and it'll return this. If it's false, it'll just keep running the program and it'll return this. It's just a different paradigm. Same exact, it's not the same exact thing, but it's the same, it achieves the same thing. So if you ever have something that's going to end that iteration of the program, if it's a loop or something and you have a break or a continue in here or something, you actually don't need the else when that happens. And so this will run as well. And it's just something you'll pick up over the years. If you're like, I don't understand that at all, again, not a big deal. Something you'll pick up. We don't need the else in this case though, just because once it hits that first return, once it hits a return, it will end. And you know, one of these has to be true. Yeah, that none type. Yeah, I did falsy. I tried falsy and it returned. Check this out. I did this. Maybe in Python that's not how you define a none type, but I did this, and yes, you can use ternary operators in Python. I'm pretty sure. I will say I love ternary operators in JavaScript. Love it. I love it. But yeah, you can use them. I'm pretty sure. I think they work a little differently. Let's actually do that real quick. And so you're gonna learn something else tonight, guys. It should not be if not name. It should be if not name. Oh yes, you are correct. You're correct. That is why. So you're right. We had a error in our logic. Not. I forgot we're using Python. I always forget we're using Python. If not name. I think you are correct there. One for you, one for me. Yes, you are correct. That was our problem. If not name. So we need to check if name does not exist. Yes, if name does not exist. But yeah, you're right. Well, if name false, it shouldn't run. Yes, you're correct. I mean, we know you're correct because it ran. But yes, correct. If you set name equals you can solve this with one line of code. Just return one for name. Oh, that's also a pretty cool trick. So great name, great trick. I like that. So what Tricetta says is, if you set the default value, to you, very interesting, very interesting. If you set the default value to you, then you don't need to do any type of conditionals, but we want to practice some conditionals, but you do not need to actually do any conditionals. How do you delete a line in what's the command? Control Shift K. There we go. You can just do this. And why can you just do this? Not this. You have to do you just do this. And so if you do not pass in any value, it'll default to you. But whoops, this is wrong. What am I doing? But if you do pass in a value, this will take the name. So how long have I been streaming? Someone get uptime in there. I don't know. Since 7, what time is it now? I've been streaming for 1 hour, 2 hours and 2 minutes plus 10 minutes. So 2 hours and 12 minutes, 2 hours, 11 minutes. Yeah, there we go. Close enough. Very, close enough. So yes, this will work as a cool one-liner. Interesting. That is great, actually. I never see these, like I'm saying, these algorithmic problems, that makes it pretty easy. And if we decide to pass in a name instead, we decide to pass in, Johnny Boy, that's someone's real name with an H after the J. Sure, let's make it work. One for Johnny Boy, one for me. That is a great one-liner. We are amazing. You are amazing, Tricetta. That's great. I like that. I really like that. I like that a lot. So one-liner. So again, you can see there's a number of ways to solve it. Again, so pull out the tools in your toolbox, try stuff out. It's okay. Whatever you get to, all those solutions we just did worked. We just tried like 5 different things, and it did work. And each of them worked. So, it's okay. Oh, how many months? Oh, sorry. That's a great question. I have been streaming. We ran the first bootcamp in August 2019, starting August 5th, 2019. But I did stream at the beginning of 2019. I streamed for like a month doing random stuff for like a month. And then I kind of stopped, started building out some stuff. And then we started in August of 2019. When you do if X is none, you call the operator is, which checks the identity of X. None is a singleton in Python. Oh, okay, none is a singleton in Python. So you're saying if you do X is none, well, we were also able to do it with not. But you're saying do, we set it to none. You're saying if X is I've never, okay, X is okay, I guess you're saying do this. I don't really feel like going back and setting up that, but okay, interesting. I do like this. I like this. Seems this is like very straightforward. It makes perfect sense. And so we can check to make sure this is gonna, we should have checked to make sure all these would solve all of our problems by running our PyTest command. Whoops. PyTest. If we run it, am I in the wrong directory? Oh, that was for Hello World. This one is twofer test. Oh, it failed again because of this period at the end, which we do not have. Boy, we struggling out here. Period. Great. Run that one more time. And all of our tests pass, and we have another properly sorted algorithm. And you can see how when we started to pseudocode it out, we had our pseudocode is all of this, and it's a lot more than we ended up getting to. And again, what we did is, the first thing we did was we made it work. So we had a lot more code, but we made it work. Making it right is like, I would actually, so yes, this is the fastest way to achieve this. I actually am not sure. I feel like even the paradigm we did before is the best, or making the default value U. Again, it gets us to the end goal faster, but I think it reads a little bit weird. I would possibly have some concerns about this, but this is the fastest way to solve this algorithmic problem. And because the application doesn't do anything else, I think it's perfectly reasonable and a great way to solve it. But see how we went from all of this to the little bit of code that we had. Also, see how much discussion, I want everyone to note right now how much discussion there's been around one of the easy problems inside of exorcism.io. What that might be doing for you right now is confusing you and making you feel like, oh man, like this is really hard and there's so much to learn. What I hope you end up coming to is that actually there's so many ways to just get to the endpoint. Like, again, use the tools that you have to get there. Don't be focused on what's the perfect way and what should it be, and like, no. Take your time, look at your, break down the problem, hit the pieces, and you'll start to see better paths as you're solving it. So go in, do what you can, and you'll say, oh, I can't do anything here because I have this structure wrong. What if I move this here? What if I change this here? And try some stuff out, and you will get eventually to your end goal. So that's pretty dope. You're able to do some weird stuff similar to that in Python 2, but they removed it. Yeah, and see, like, I think it's actually going to be interesting to, no, it's not. I'm not going to confuse you. We'll do that later. We'll do I will tell you right now, the escalation between this introduction to algorithms tonight and when we get to algorithms 2 is going to be vast. And again, it's not to scare you. It's to it's interesting at how many concepts even a problem like this shows. And then once we get into some of the more traditional algorithmic problem solving types, I think it's going to be a much bigger cognitive load, but not so much for programming, but just so much for problem solving. But it's okay, we'll get there. So that's 2 for 1 for you, 1 for me. Great. We're not gonna do pling plang plong or raindrops or whatever it's called, because that's fizz buzz, and we just did fizz buzz. I would like to do something that test gives us a different thing. So if you actually read through this, it's actually like the fizz buzz problem we already solved. We'll do this together. We can do this together another time, but I actually would recommend going back. If you go back and watch how we did fizz buzz, I bet you could watch that even if you didn't understand anything that we did. I bet you could watch it, and I bet you could apply, like you could take it You could look at it, you could download what we did because I pushed that up to GitHub. You could modify it to make this raindrops thing work, I bet. So let's look at high scores. I don't remember ever doing this one. I'm sure I've done it before. Very interesting. So what does this one say? This says, manage a game player's high score list. Okay, we're gonna do this one. We're gonna do it. I already feel like, because of the amount of words they've given to us and the lack of code that they've given to us in the example, that this is probably going to be actually, we're not looking at it. This is actually going to be a little more difficult of a problem than we've seen. I don't know this yet. I don't know this at all. Maybe it's easier. But take a look at this. Also, actually, I'm gonna go back real quick. Take a look at the, again, if you want to work on certain things, I recommend actually, I do recommend switching up topics by the thing you're trying to learn. So if you're just trying to, get comfortable, really get comfortable with strings, click the strings one and start to learn those things. You'll learn a lot more things. So this one has sequences, text formatting, we're not going to do this one. We're not going to do anyone with classes right now. So let's stay away from that one. Let's go with hamming. Hamming might be too, okay, we're gonna do this one. We have 20 minutes. We can finish hamming in this amount of time, but this is really gonna feel like what you probably expect a coding challenge to feel like. Maybe Twofer was that for you. This one will probably feel more that way. I do like the hamming one because this was the first one that got me excited to realize they're going to teach me more on here than just coding challenges. I learned about something through this one. So let's read this really quick. Introduction. Calculate the hamming distance between two DNA strands. Already. Oh, so I want you to also understand the psychological aspect of the topic that the coding challenge is talking about. Already, talking about the distance between hamming's a word you don't know. Hamming distance, you're like, bro, what is that? Between two DNA strands, you're like, oh my gosh, crazy. I feel you. Again, these are coding challenges. All the extra stuff is extra. We'll read it. We'll comprehend it. We'll break it down into the pieces that you need to solve via code. So your body is made up of cells that contain DNA. All these extra words are just here to throw you off, okay? But your body is made up of cells that contain this DNA. I'm just going back to my high school times, and I think DNA stands for deoxyribose nucleic acid. I have no idea. That just comes to mind. Let's actually see that. What does DNA stand for? I just want to see if I still have it. Deoxyribose. Yeah, look at that. I'm so smart. Deoxyribose nucleic acid is what it stands for. Makes up our cells, our sweet DNA. And so, it's made up of those cells. Those cells regularly wear out and need replacing. All right, which they achieve by dividing into daughter cells. This is confusing me already. In fact, the average human body experiences about 10 quadrillion cell divisions in a lifetime. Quadrillion is exactly quadrille zeros. So just go look at. I made that up. I have no idea. I have no idea how big the number quadrillion is. It sounds very large because it does a lot. Let's see. When the cells divide, their DNA replicates too. Sometimes during this process, mistakes happen, and single pieces of DNA get encoded with the incorrect information. There are a lot of words here. Actually, whoa, the stream is far behind. I wonder why there's so much, there's usually not this much latency. That's fine, not a big deal. But lots of quadrillions, lots of, sometimes during this process, single DNA gets encoded with the incorrect information. If we compare two. Okay, so now we're getting into the part. I like when they put words like if in here, because now it tells us kind of what we're going to be looking at. If we compare two strands of DNA, two different strands of DNA, and count the differences between them, we can see how many mistakes occurred. Ooh, okay. So now we're talking about comparing two things. We've already learned that we can do, comparison operators. So we may be able to figure some things out. So if we compare them and count the differences between them, we can see how many mistakes occurred. This is known as the Hamming distance. So break it back down. Sounds like the Hamming distance is the amount of differences between two DNA strands. That's what it sounds like to me. We read DNA strands using the letters C, A, G, and T. Man, this is it's very interesting. It's very interesting that this is kind of like a SAT question, where the logic for this isn't that crazy, but you've got to use your knowledge of language. You've got to use your knowledge of problem solving to kind of pull out the important pieces. But we read the DNA using the letters C, A, G, and T. Two strands might look like this. So this looks like an example here. And we've got some letters. And it looks like the arrows are only under the letters that are different. So G and C, they're different. So an arrow. A and A are the same, no arrow. G and T are different, so arrow. Okay, so it looks like it's showing where in the sequence there are differences. And it says here, they have 7 differences. And therefore the Hamming distance is 7. The Hamming distance is useful for lots of things in science, not just biology. So it's a nice phrase to be familiar with. Implementation notes. Ooh, this one might be kind of tough for us. The Hamming distance is only defined for sequences of equal length. So you can only do this for 2 DNA sequences that are the equal length. You should automatically be thinking of how to check this. We know how to check the length of a string. You should be thinking about that right now. And you can only run this if they are of equal length. So let's start writing some stuff down real quick. So you can only run them if they're equal length. So an attempt to calculate it between sequences of different lengths should not work. The general handling list is may differ between languages. Okay. All right. So yeah, lots of filler text to distract us. The actual problem is 2 to 3 sentences. What's up, Thug Muffin? Good to have you. Welcome. Good. Come on in. Sit down. Good to have you. We're just doing a little bit of what's this stuff called? We're doing the Hamming. We're doing the Hamming distance. We're doing a little bit of problem solving here. So, one of the big things we need to do is if we break this down, really, it sounds like we need to. It says in here if we compare 2 strands of DNA. So we need to compare 2 DNA strands. And so we learned about all kinds of comparison operators. And it says, all right, we're going to count the differences between them and see how many mistakes occurred. So really, I'm just going to write down, we want to compare 2 DNA strands and we want to count the differences is what I'll just put here as like what we need to like actually do. Count the differences. And so we also need to know if, this is right here, it's only defined for sequences of equal length. So an attempt to calculate it between sequences of different lengths should not work. So only run if DNA strands are of equal length. All right, so we got that written down here. I have this just over on the side to just whiteboard it up for you. I just have compare 2 DNA strands, count the differences, only run if the DNA strands are of equal length, and no, count the differences is pretty important. So this is I'm going to basically run through a lot of this for you. Let's download it. Let's look at the code that they give us, and let's see what this looks like. So I'll download it so I can give it to you real quick. But this one's going to be pretty interesting, actually. Get exorcism. copy dash R. I'm gonna copy that here. And Academy, we're gonna do get add Hamming, get what am I doing? Get commit dash M added Hamming distance to exorcism folder. Okay, those are up in the repo for you. Again, if you do another git pull, you should be able to get that if you didn't use exorcism to already download it. So let's get going here, and let me see if I can get, man, it's way, well, at least on my end, it's way, what you all are seeing is way behind where I'm actually at, but all good, not a big deal. It's just making my chat experience a little weird for when I'm responding to you, but no big deal. Let's see. We're gonna go into Hamming. Okay, this, like I said, this is gonna stretch. This is probably gonna stretch all of our knowledge on the things that we've learned so far. I think we're actually gonna touch like most of the things that we've learned so far, and so I think it's gonna be fun. And let's check it out. Let's take a look. I'm not even gonna look at the test right now. I'm just gonna look at what they gave us, and let's break down what they gave us, and let's start building out some stuff. So they gave us a function, our subcode that they gave us. They gave us a function, and that function is called distance, and it takes in 2 arguments. It takes in strand A and strand B. Why is this great? It is great because the first thing that we are going to be doing is we are going to be comparing 2 DNA strands. So it sounds like it's already taking in 2 different DNA strands. So great, strand A and strand B. It could be strand 1 and strand 2, whatever. Excellent, great. So now we must compare them. And so you may want to start by doing something very, very simple. All right, we're low on time, but you may want to start off by doing something like this. Say, hey, if strand A is equal, is equal to strand B, we want to count the differences. So actually we want to do that. It says compare the 2, count how different they are, only run if DNA strands are of equal length. So maybe that's the first thing we want to do. We don't even want to run it if they're of different length. So how do we check length? The way that we check length is if length of strand A, and so that'll give us back a number. So however long strand A is, it'll check. We'll say if that's equal to the length of strand B, then go ahead and run code. And this is kind of our pseudocode. So maybe just to get started, we'll say return, they're the same length. So we'll say this program will run. And if not, let's just return this will not run. And so this is a good way. This is a good way for us to very quickly test if we've done the logic to see if this program will run or not. And so we can practice, and we can say distance, and we can go ahead in here and we can grab in the readme they have a Hamming example. Let's grab the 2 of these, and we already know these are the same length. You can kind of see it. It's pretty easy to see. So that's strand A. Strand B, we're gonna pass on to strand B real quick, and that strand B is going to be this other one. And so we'll just use their exact example for us to try to, get to the end, because we already know there's 7 differences between them, and that it will compare them because they're same length. So if we run this really quick, this will determine whether or not our logic to run the program actually works. And if we run it, nothing happens. Why not? Because we are not printing anything. So let's print this. Let's see, let's actually print the value of this output. And let's say Python, let's close this over here. Python 3, what's this, hamming.py. And it says, this program will run. All right, great. This program will run. So our logic is pretty good. How can we test to see if it won't run? Let's take off a letter. Let's take off the T off of this one. This makes them of different lengths. They're no longer of equal length. So if we save that and we test it, it should now say this program will not run because they are of different lengths. And now it says this program will not run. So we've achieved that last piece in here in the README where it says down here, the Hamming distance is only defined for sequences of equal length. We've kind of at least set up the logic to determine whether or not it will run. So now we've run the if statement. We says, hey, if the length of string A is equal to the length of string B, go ahead and do some stuff. So now we can run some code. Now we can go ahead and say, all right, what's the code that we want to run? We need to compare the two strings and see if they're different. So you could run another if statement in here. You could say, hey, if strand A is equal to strand B, then say they're equal or something like that. You could start there. You could check the first just to see if the strings are equal at all. You could do that, but for the sake of time, that's kind of how I would start. I think it's a good way to start to mentally walk down the line. But what we really need to do is not just compare. We're not just comparing the string, the entire string itself. We're comparing each individual item in the string. There is a number of ways to go around and do this, and it's pretty interesting. Let's start to think through some of the things that we've learned. Some of the things that we've learned to help us to iterate over something is our loops. The loops, we can use some collections to do that as well. We actually learned something else last time. We learned a function that actually split up a word into different characters. But check, let's drop really quick into the Python interpreter, and I'm gonna say x equals hello. Okay. I think that we learned, so I think this works in Python. I think that you can actually iterate over the individual items in this. And so maybe I can say, I think you can do this, maybe not. I in X, go ahead and print. All right, let's see if this works. I don't know if this works, or if I can write it like this. It does in fact work. Oh, what are we eyeing? What are we eyeing? I told you my stream is behind, so I don't know. It's way behind actually. Hold on. X equals. Oh, actually, no, it's not. It's catching up. It's definitely catching up. But it does in fact work. So I did for I and X. Yeah, it definitely caught up. It was really behind for a second, but it did print. It did in fact print this. So I ran a for loop, and I wanted to print each letter in this object, in the string hello. And I can actually use a for loop. I can actually use a for each loop. So we learned about for loops and for each loops, and I'm basically running a for each loop that says, hey, for each of the letters that are in this string, go ahead and print them out. And I'm able to print them out right here. And so if we take that over here, we can use that same paradigm to compare certain things. Or remember, check this out actually. We talked about indexes. These letters in Python are also indexed. So if we did something like this, like X of the 0 index, so this thing here, hello, of the 0 index, the 0 index is the first spot. We hit this, no matches. Oh, I'm actually not in the Python. interpreter, we did X equals hello. And I do X of 0, it does the first letter. So now we know that we can also refer to a letter by its index. So this is very confusing. Like I said, this is what I said. What we're going to talk about now is going to really stretch what you know, if not completely blow it out of the water. So don't sweat it. You're learning a lot. You're seeing a lot here that is going to be new. And so we can refer to this by the index. And so what we can do is we can use that index to determine whether or not we can use that index to refer to the letters in each of the strings. Okay, and so let's move this a little bit quicker. I'm giving it to you in a rather verbose way up front, just so you can see a number of different concepts. Now, if A and B are of equal length, and you can see here that basically it's comparing the strands. So right here it's comparing the things in the 0 spot, and here it's comparing the things in the 1 index spot, and here in the 2 index spot. So what we can do is we can use that number to refer to a couple of different things. So we can say we can set up an iterator, and again, this is we can use a while loop here. So let's use a while loop really quick. I use a for loop there. I can say I equals 0. So I can say we're gonna start at 0, and I can say while I is less than the length of either strand. You can pick one. I'm gonna say strand A or B because they're the same length. They're completely the same length. I can say, so what is this going to be equal to? So how many letters are in this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17. It's like 17 in there. Maybe I'm wrong. I don't know. So it's basically say while I is less than 17, that's what it's going to evaluate to. Go ahead and do something. And what I'm going to do now is I'm going to use that to compare the letters. And so I'm going to say, all right, if strand A is equal to strand B, but not just strand A is equal to strand B, strand A of whatever index. So we're going to be iterating through these things. So I'm going to say of I. And so what it's going to do is when I is 0, it's going to compare the first letter of strand A to the first letter of strand B. All right, and it's going to do something. We're going to determine what it does, but then once that's done, we're going to need to add 1 to I, and the next time it goes through, it's going to then add in the first index. It's going to add the number, A of 1 to B of 1. It's going to compare those second letters, and then 2, and then 3, and so on. It's only going to do it for however many letters are in, or however many things are in that string. So we're going to say, hey, if they're equal, and we're gonna say if they're equal, go ahead and continue and go to the next iteration of the loop. Just keep going, not a big deal. But if they're not, actually, let's do it this way. Actually, make it a little simple. No, we're gonna check if they're equal, continue, and if not, we're going to do we're gonna need another thing. We're gonna need to count the distance. So let's create a little variable up here that says the Hamming distance. That's what we're calculating. The Hamming distance, we're set it equal to 0 because by default, we haven't compared anything. The Hamming distance is 0. But if they are different, so right here it checks if they're the same. If they're the same, we don't need to add a number to the Hamming distance. We can just continue. But if not, if they are different, we need to add 1 to the Hamming distance. So now we can say Hamming distance, and let's use one of our operators, plus equals 1. This is our arithmetic operator, plus equals assignment operator. We're going to add 1 to the Hamming distance. So what does the continue keyword do? The continue keyword says, hey, go ahead and end this iteration of the while loop and go back up. So if we hit continue, it will not run this bit of code down here. It will just go up to the next iteration of the loop, and so on. So we're going to check if they're equal. If they're equal, hey, keep going. If they're not equal, go ahead and add 1 to the Hamming distance and go to the next iteration of the loop. What will then happen is, we get the return down here. all we're gonna do is we're gonna run the whole thing, and at the end of the entire thing, let's go ahead and let's run. We're gonna return the Hamming distance. Return the Hamming distance. So this is gonna give us some numbers. So we're gonna compare these two right here, and this is actually going to give us, I think, our answer. And we'll break this down again. I know it's a lot. I know it's a whole lot. What's up, the goat? How you doing? Good to see you. I will read your thing, White Hole, in a second, but we're gonna run this. Ooh, and it's running, it's stuck. It's running in an infinite loop, and let's see why. We can see why it's running in an infinite loop. I told you that you will run into infinite loops. You will 100% run into infinite loops. And the reason why we're running into an infinite loop is because we are not increasing our count. So our count is always 0. I is always 0 here. And so what we need to do is we can do a number of things. We can do we can do it here. I mean, we can do this is why a while loop may not be the best for this, but maybe it is the best for this. And so we need to add 1. We can do a for each. For each is great. Yes, for each is probably a better option, but we're going to continue with the while loop. And what you can do is, like I said, I want to be verbose so that you can start to see why things work better than others, and why, like, you'll start to see those things. You'll run into problems like this. And so I could say, you know, if it's true, go ahead and I plus equals 1. We'll add 1 to I here, or we can just put it in twice. You know, I mean, this is a bad practice. This is wrong. Not wrong, but you know, we're just making it work. We're making it work before we're making it right, and before we're making it fast. And so I can put it in 2 different places. So this will only run once. One of these will only run, but we can just do that. We can do exactly that. And again, I don't recommend that. Adding a single iterator is probably the best. For each doesn't work as you loop over 2 arrays in parallel. For each will work with range, because range, yes, oh, you put it right up there. Range will give you an iterator. Range will give you an I, 100%. But I think that's a pretty confusing concept, actually, if you don't understand the iterator, which is why we're using the actual iterator like manually here. But 100% for each with a range is the best option for this. It is the best option for this. But again, I said we're going to be a little bit verbose. And I also want to highlight that you can use, remember I said you can use these loops relatively interchangeably. Again, some work better in certain circumstances, but you can use them interchangeably. But look at that. Using the incorrect method, we were able to get a 7. And we already know that this said that the distance was in fact a 7. And again, so basically what happened is, and I could put some print statements in here to show you exactly what's happening. And let's do that real quick. We're gonna say, let's do this. Let's say, we're gonna say is print real quick. I'm gonna just put in some stuff so you can see what's happening. We're gonna say is, put an F here, is strand A of I equal to strand B of I. Say this real quick so you guys can see exactly what's happening here. And then we're gonna say down here, print yes, they are. Or down here, print no, they are not. And now we can see exactly what's happening to make it a little less confusing. Hopefully, let's see if this runs. And all right, now we can see it line by line. We can say, hey, is G equal to C? No, they are not. And actually, let's put in one more print statement. Actually, no, they are not, comma, adding 1 to the Hamming number. So now we know exactly what's going on. Adding 1 to the Hamming number, or the Hamming distance. run it again, and here we go. So now we can see how we got to 7. Is G equal to C? No, they are not. Adding 1 to the Hamming distance. Is A equal to A? Yes, they are. Is G equal to T? No, they're not. Is C equal to C? So you can actually see exactly what's going on. I'm gonna push this code up for you so you can try to run it yourself and kind of see what's happening. And I encourage you to play with it and try to run it. This does not, I do not think this will solve the problem, the actual test, because of the way we wrote it, but we went through and we solved the problem, not in the most elegant way. You say you would never figure this out, you would be surprised. You're not figuring it. It's so watching someone else do algorithms is actually more confusing because you don't think the same way that I think. And right now I am trying to, like, when I'm going through things, I'm trying to enforce, like, the way that I'm presenting it to you is in the way that my mind works, and it could be completely throwing you off. I highly recommend you sit down by yourself, work on a problem, like completely isolated, and see how you get to the solution. See how your mind takes you different places. I'm probably confusing you because of just the way that I think. Some of you may understand exactly my path forward, my mental thought. And I also went through a relatively tough problem that I could have easily taken an hour to show you in like 13 minutes or something like that. So don't sweat it. I just want you to see, one, that although there's a lot of stuff going on here, we did not use a single thing that we haven't learned yet. That we did not do anything out of the ordinary. We used the if statement, we used length, we used the while loops with the I here, we used some prints, we used the continue, which we learned about with the loops, we used the assignment operators plus equals, we returned. So we didn't use anything new. So that's why I was trying to tell you that you pick up the tools and you can use the tools to solve your problems. It takes time. It takes energy. I encourage you to, try some out yourself. I encourage you to watch someone else work through FizzBuzz. I encourage you to watch someone, I encourage you to Google. I bet you on YouTube, there is a series. I bet, I have no idea, but I bet there's a series of someone explaining all of these problems on exorcism. And if there's not, I'm going to do that because that sounds pretty cool, but I think it should be fun. Too late for the recommendation engine? No, it is not. I think we're right at the right time. But that's it. Tangible takeaways for tonight. What are the tangible takeaways? How do you approach solving problems? What are algorithms? First off, algorithms are just a process, a procedure to be able to solve a computational problem. It's just it's a process for getting it to an end goal. That's all it is. It's not any fancy math. It is just the steps that need to be taken to get to the end goal of a problem. That's all algorithm is. And to solve algorithms, you're really just solving a problem. And how do you approach problem solving and coding? One, you need to first comprehend the problem and what it is that you're trying to solve. Read it 20 times. Use whatever resources you have available to you to ensure that you comprehend the problem first. You got to understand it first. Take your time, understand the problem. Two, once you understand the problem, and even before you understand the problem, start to break it down. You might understand the problem more when you break it down. Break down the problem into manageable pieces. Inch by inch, life's a cinch. Break that problem down so that you can work through it. Three, if you need to, write some pseudocode. So don't immediately hop into writing code. Start to write down on a piece of paper just the logic that you're going to go through, and maybe draw some arrows, maybe draw a diagram to figure out logically how you're going to get to the start to the finish, how you're going to solve those individual pieces, and then start to code. Start to pull those tools out of your tool belt and start to think about the things that how those can fit into solving your problem. And again, all that, you'll get better at that over time, but that's kind of just the base level to be able to get through all of that. So that's that. That is that. Justin Hazel, why are you not outside protesting? Because I'm in here teaching you all. Hey, everyone has their time. Everyone has their the way that they contribute to certain things. Maybe I'll be out there protesting tomorrow. That's why I'm not out there right now, because I'm here with you all. Why aren't you out there protesting? I guess that's the question. Why aren't you out there? So all good. It's all good. We're not tripping. We ain't tripping over nothing. But oh yes, that Python recommendation engine. All right, so it was for I don't want to just type in GitHub Python recommendation engine because that's going to bring me up everything I found yesterday. But I'm going to type it in and see if I can find it real quick. But that's it for tonight. If you want to get out of here, you can skedaddle. All good. I appreciate it. Next week we are back with what are we back with? Oh, we're back with object-oriented programming. So remember when we got to that problem, but I was like, ooh, classes, like I'm skipping that one. We'll be learning about object-oriented programming, which is a programming paradigm that you can use to solve some cool problems. But yeah, Python is an object-oriented language. There's some other good object-oriented languages we'll learn about what that means, how to do that as well. And then we'll be learning about functional programming after that. So object-oriented first, functional programming second, all good. And then on Saturday, if you're interested in the pipelines course, I have no idea what we're doing in pipelines this Saturday. Pipelines Journeyman, we are doing we're doing a little bit more CI/CD stuff. We're going to be still setting up some CI/CD as well as working on converting our monolithic repository of multiple applications out into microservices, so individual repositories, smaller tools and things like that, and setting up some continuous integration between them. So you can check that out if you are interested in that. But let me see, where's the one that I found? No, I think I found it through I think it was through a movie engine thing. None of these are, it has a lot of stars. I'm trying to remember who. I remember the company yesterday, but I don't remember the company today. I don't know. I'm gonna look and I'm gonna shoot you a message, Diarrhea. I'm gonna try. I don't know. Can you read me your earlier message? Yes, I can. I can read your earlier message that I said I would read and I did not. I made a solution to the twofer puzzle from Exorcism, and if you have time in the stream, I can highly recommend you take a look and show it on stream. Yeah, let's do that. Where can I find it at? Where can I find that at? Yeah, let's check that out. See, you already have. I already don't like this. It's too much already. Too much already. This is you did it in Java. First off, thank you. I don't find this funny. I don't find this funny at all. Is this I know some guy made like a huge one. Did you take this from that? This is too much. I'm not reading it. I'm not reading, but very, very interesting. Thank you for that, because you could do this. You can make it just as hard as you would like to make it. Java it's not Java. What is this? What's KT? I don't know what KT is, but what is this? Actually, hold on, let me go back to the main of the repo. So initial commit, I have no idea what this is. You have some gross XML in here. Well, Kotlin's Java. Kotlin's Java. That makes sense. KT's. Isn't Kotlin like was this like a superset of Java, isn't it? Right? I'm pretty sure it is. Too much. First off, I don't even know what I'm looking at, to be 100% honest with you. It's a lot. I want to find, where does it start? Oh, two for salute. Is this? I feel like this is your actual solution. Really? Oh, it just targets the JVM. Okay, that's very interesting. I think the reason why I thought it was the same is because what's it called? Jenkins uses Java, and then they started to use Groovy. They started to use Groovy to be able to implement things, and they also have started to allow Kotlin. And I thought they were similar. But I guess not. Maybe I'm thinking of Groovy actually. When I say Kotlin, I might be thinking of Groovy actually. Why does it have 10 folders for 3-line solution? It starts in main.kt. Well, let's see if we can trace it really quick. And your excuse me, I need you to anything that starts with, first off, for a twofer, for anything that imports more than 0 things is too much. It's too much. Oh, good lord. Object main fun twofer. So fun must be function. I don't know Kotlin at all, but we're learning some Kotlin, and we're saying that we need an input, which is a string, and it's probably going to return a string. Nice. We're setting up a variable input factory. No idea what that is, but this is this is interesting. Didn't pass anything enterprise test. The enterprise test. That's fair. That's very fair. This is impressive. This is impressive, and I don't like it. I don't like it. It's making me uncomfortable right now. It's gross. It's gross. I actually have heard good things about Kotlin though. I'm interested to know what you think about Kotlin. I've heard the people who use Kotlin seem to like it a lot. What is Kotlin used for though? Like, I'm sure it can be used. It's probably like a general purpose Kotlin. And Kotlin's is Kotlin functional? Like Kotlin's functional. Makes developers happier. Open source forever. I'll check out Kotlin. Let's Google real quick. I'm actually really interested right now. What is Kotlin used for? Why used for Android development? Okay, and maybe that's also why I got Java. I thought it was related to Java, but it says it builds the JVM, or it targets the JVM, which is kind of nice. The Java alternative. Okay. Outside of Android development, let's see, what do we got outside of Android development? One common library. Okay, well, I now know all I need to know about Kotlin. I'm now Kotlin Pro. I know how to make a function in Kotlin, and I know how to make variables, which means I can solve every problem that I'd ever want to solve using Kotlin. But no, that's pretty cool. That's pretty cool. I do want to start to explore some more languages. I'm not sure. Maybe if I find a reason to use Kotlin one day, I'll absolutely use it, even though I do not like the JVM at all. Maybe can Kotlin build to other targets besides the JVM? Or is the JVM just the common thing that it targets? I'll check out Kotlin. But dope. Who are we rating tonight? Who are we rating this evening? DevSecOps in the government, Java Spring Boot. Yeah, the government loves Java Spring Boot. I will never work or touch that language again. I mean, I've heard a lot of people say that. Whoa. I was wondering where all the sound was coming from. My laptop. Kotlin can build to the JVM, JS, and LLVM. Yeah, okay, that makes sense. That's interesting. I'll check out Kotlin. Like I said, I think Kotlin was one of the languages that's also has been like growing and growing on Google's like most wanted, not Google's, on the GitHub developer survey every year on kind of the most wanted languages and stuff. People seem to like it a lot. But yeah, let's actually head over to Alt F4 tonight. Right here on the front page, they're doing some open source cloud in Go. That's all the stuff that we do here. So we'll head over to Alt F4. We'll say hello. Yeah, let's say hello. But that's pretty dope. Your implementation is interesting. I'm actually going to go through and actually like read through it and see if I can understand what's happening, because it's pretty interesting. But I have seen some interesting. I would love to see your take on like FizzBuzz or something. Another language I can't. Yeah, I mean, I'm telling you, once you wrap your head around the major concepts, it's relatively easy to go through and kind of figure some of those things out. Relatively. But can I raid from here? I don't think I can raid from here. I think I have to raid from here. But like I said, we'll be back next week with some object-oriented programming and some functional programming. And this weekend we're gonna be doing some CI/CD and talking about some microservices and stiff stuff like that. And let's head over to raid the Alt F4 stream and say hello I love you all. Everyone have a great evening. Relax a bit. Take some time for yourselves. Take some time to your family. Like I said, we're in tough times. You know, love each other. Please love each other. You know, meet everyone with open arms, open heart. You know, just maybe it's time to, you know, just talk to people. Spread some humanity. See people as people. People are going through tough times right now. Whether it be COVID stuff or stuff going on, you know, with George Floyd, all that stuff. Again, just be kind. You know, we're all here together. We're all, you know, we're consuming the same space. Let's treat each other accordingly. But have fun. Good night, everybody. Let's say what's up to all that 4 and peace out. We're out in 10, 9, 8, 7,
6, 5, 4, 3, 2, 1. See you all another day.